Hello everyone. This is the announcement about next talk. So, are we ready to start? If you want to tweet about this talk, please use the hashtag PyCon APAC_1. Please use hashtag PyCon APAC_1. Okay, now we are going to start Tuya-san's presentation. The title is Beaming Up to the Flow. Before the presentation, the speaker will read a statement as a microphone test. So please.
This is the mic test. My name is Tuya Cho. The title of my talk is Beaming Up to the Flow. My presentation will be in English. The material will be in English. I will try to publish my presentation materials, and I agree to have my presentation and pictures recorded and taken. I will comply with PyConJP Code of Conduct.
Thank you. The presentation time is 30 minutes, including questions and answers. Please welcome Tuya-san with applause.
Thank you so much, everyone. And I hope you are all ready after the big keynote. It's a bit long one, but I will make it short and interesting so you don't have to feel bored after this session. So this is me. I just flew in from Singapore a few days ago, and I'm currently a senior relationship engineer for developer at Google Cloud. And for my day-to-day jobs, I kind of help to improve the experience of developer for the platform. And I'm also fascinated about whether we are in a simulated war or whether the aliens built the pyramids or not. So if you have similar thoughts, we can have a discussion after this talk. So when I just joined Google, that was about 2 years ago, they throw me into this project called Fraud Finder. And I have no idea, right, because new company, new to the teams, so I just have to figure out how I can navigate around. And the cost, like the events, it happens like that. When the user purchase something, like you probably buy it at their company or somewhere else, where you tap your card or your phones or your IC card to purchase something, you actually trigger an event, right? So you don't see it, but at the back end, it triggers an event, and it looks like this, right? You have a transaction ID, something gibberish that you can't really tell, and you have timestamps that attach to it, like when you purchase it. Don't talk so much about the time zone at the moment, but it's just timestamp. And we have a customer ID, right, because your card, so you kind of know who you are. And then the transaction ID, basically where the terminals, right? So in a company, you probably have like 2 or 3 of terminal. Which terminal is the card tap on? And you also have the amount, right? So although we're just tapping one tap, it probably take maybe 2 seconds, but at the back end, there's a lot more data being generated, and then it's pushed to the server, right? So you have these kind of records every single tap the customer make a purchase, basically. So creating machine learning, the goal is that you have like a data that has so many attributes, customer, ID, terminal ID, the amount, the times, and all that. And how you want to make sense is to put that into a model. And then hopefully the model can sort of tell you whether the transition is actually a fraud or the actual transition from the customer. It's important because who like your money being taken away for nothing? Anyone? Nobody, right? So exactly. So this is how the banks try to protect you from having fraud, right? So there are even, so there's a fraud detection system from the bank. There's a fraud detection system from the company. Like the store that you purchase, their fraud detection system. So it's like fraud detection inception, basically. They keep detecting every step you do. Okay, so thing is, this is how the typical machine learning flow looks like, right? So you have a data, and of course you have to collect the data before you do any machine learning stuff. And we have to create a features which we call the input for the model. Right? Before you do anything, you have to create input. If not, the model can't do anything. So you create feature engineers, and then you start building the model. And then after you have the model, of course, you have to serve it, right? So either you integrate into the model or the workflow, or you have to serve it as the endpoint, as the API. For this talk, I'm going to just focus on the feature engineering part. I think this is where exciting things going on. Anyone is a data engineer at the moment? A few folks. And it's a challenging job, actually. Although, you're just kind of like moving data around, but it's kind of challenging. I tell you why it's challenging, because this is kind of like my first time working with streaming data, and it was really painful because I spent like 2 weeks trying to figure out how to even, chunk the data into pieces. So before everything else, right, we used to live in a world where MySQL was a thing. Like you can kind of like store your data into a laptop and then you host it, right? There's nothing about cloud. There's nothing uploading anywhere. Just hosting a local server. Everything was peaceful, good time, right? And probably the whole shop can fit into like one database, right? Then now we are living the big data world, right? Like it's not just about the whole data, right? You can't even fit in like 1 day data in a database anymore. You have to have like elasticity, you have to have like scalability, replications, backup, so many things going on, right? Even caching, right? So think of like big data as really, really big data. You have massive data coming in from day to day, right? Not even like the whole period, just 1 day. You have like so many data coming in. It could be terabyte to petabyte, right? And sometimes the data are not stationary, right? You don't get data like every end of the day. You get as and when the customer do something, right? So this is where things get trickier because you don't know when the data are coming in. So you have to kind of prepare for it, right? And you don't even know when the data are going to end, right? Like, let's say you buy something at 7-Eleven, then you buy one more time because you forgot to add it in or something, right? Like you can't predict this kind of events from happening. So this is where data get complicated. Because some data, maybe due to like network connection, maybe something happened, it arrived late. I purchased at 8 o'clock, data transferred to the company at like 7, right? So there could be so many things going on, and you don't even know sometimes whether there's a late data coming in or not, because you can't see the future, right? Anyone can see the future, by the way? Oh, there's someone. All right, please talk to me after that. I want to know about my future. Yeah, so this is why we need to be reactive and preventive of this kind of data, because we don't know what's going to happen in the future. I mean, except the gentleman over there. So the requirement given to me, it was simple enough, right? Like, you are new to the team. We have this streaming data pipeline going on. So what we need to calculate is the number of transactions within 15, 30, and 60 minutes, right? And the amount and average. Very simple, right? So let's start from this table: average, means, and max. Done, right? That's not how it works, I think. So some challenges, because there's no proper beginning or ending. So I keep asking them, like, what's the start date? It's like, oh, there's no start date because it's been running for days. So you have to decide where you start. And like, I don't know when it's gonna end, right? So if I do select star, like now, and like 1 minute from later, the results are different, right? So when I'm doing it, different results. When I'm showing to someone, different results. So it's always changing, so you can't do that. And some records can be late. Also, amount that you receive, maybe everyone wake up, start buying Shopee or Lazada or something. I don't know. So the amount of data is coming in is kind of hard to predict. I don't know how much is coming in. And I need to process the data on the fly, right? Because I can't say, oh, I'll wait for like 1 hour, I will give you the data. It's not how streaming works. Streaming, you need to be on the fly itself. And accuracy is important, right? So you probably see some memes about, oh, I can do math really quickly. Then you ask, then you say some number and say, oh, you can do it fast, but yeah, it's not accurate. I can do it fast, but not accurate. So it doesn't really work that way. So how I discovered this is called Apache Beam. It's an open source unifying programming model for batch and streaming. Right, so it's just you use one disk package, and it kind of works for both streaming and batch. So batch is like stale data. So you have like a set of data, and then you use just same pipeline just change the type of like parameters, and then it works for both streaming and batch. And you can even combine the two together. So this is how I started learning Apache Beam. And it works for large-scale processing. So it's not just work for your company, work for your laptop. It works across, right? You can use it on a cloud. You can use it for the multi-processing as well. So I started tinkering around, and I found out it's very easy to use, right? So this is one sample code of it. All you have to do is just import Beam, and then you create a pipeline. From the pipeline, right, you can just say, like, there's some data coming in. So there's, like, there's an index key, which is in this case, is the emoji. And then I just have to group by the key, join the words using the lambda functions, and then I print the results. So it's very Pythonic in a way, and it's also, except the pipe. You don't really see pipe in Python most of the time, but this is Pythonic in a way, and also you can use SQL-like syntax, like group by key, right, select star from here, and all that. And I also figure out you can actually use SQL syntax itself inside to create some kind of transformative, right? So think of it like a custom Python function that you write that will scale at the back end for you, basically. So once I found out these tools, and they have a few tools that you can work with the streaming data, right? So it's not decided by me, it's decided by the creator. So how they do it is they process the data by time, okay? So you can't really know when it's gonna end, but you just block it off by time. Let's say per hour, right? I just give you a like sliding window kind of thing per hour. So I break it down by hours. And then there are 3 dominant methods you can use to kind of like process your data. Right? One is called fixed window, like we just mentioned. So I break it down by 10 minutes. So I will only process the data within the 10 minutes, right? So regardless whether you come late, you come early, I don't care. I just chop it off. That's my fixed amount of data. I just process it, and then I put it out, right? Average, means, all that, within the time block itself. But sometimes it's not useful, because I might want to see the average maybe within an hour. You can't do that, because it's just by time block. You're just moving all the time, right? So I don't want the moving one. I want kind of like overlap, right? So you can also have this thing called sliding window. So this is where you start to see things like, hey, what's the customer purchase amount over the last 15 minutes? Because it's always sliding. So you can kind of see the progress of the customer. And you can use this to do like moving average, right? So you probably heard of moving average all the time as well. But it's still within the time block, just that there's some overlap element to it, right? So when you're doing this kind of thing, you have to know that this is overlapped. And another one is more usable for like user activities, is go by the section. So you can define what type of session. It could be I logged in, and until I logged out, that's one session. So you can do things like calculate the number of activities the user did for the one particular session, and then when they log back in, then it's a new session, right? So you compress by sections. And you can define it, you can write your own custom session function so that you decide what the session looks like. So I tried all these 3, and the one that works for me is the sliding window using the offset, right? So I do not know when the data has started, but if you use Apache Beam, you don't have to know, because the Beam would figure out what was the latest or the earliest data available. Then they started framing the time blocks from there. So based on the timestamps that you have on the data itself, it smartly know when to go and then break it down until it is reached to where you are right now. So every time the new data come in, because I need it like real time, so I do it 1 minute time blocks. So I'm just moving my detection every 1 minute, and then I process it on the fly. Okay, so this is how it looks like on the paper. And some challenges that I still have is it solves the no beginnings or end problem, because the Beam kind of like take care of that. Even if the records are arriving late, I do by time block, so I don't really care that much of that. And I still need to solve this problem of unpredictable data, and I need to process on the fly. I can't be opening at night to process it on my laptop, right? And this is where I started using Dataflow. So Dataflow is managed Apache Beam, right? So it's the same code, same library, just that it's managed. All you have to do is just upload it, change the runner type, and then you upload to the cloud, and then the thing is all handled by Dataflow itself. Right? You don't have to change any code at all. So usually deployment takes a lot of time and effort to like package it and all that. This one just changed the runner type and it just runs on itself, right? And the open source community-driven approach to this is that when you have new products coming in from Bean, it's get reflected directly to data flow as well, because they are kind of like work together. I think data flow came first, and then Bean comes, I think, because they open source that part of it to that. So I'm going to show you some of the demo. I think I still have a lot of time to do that. So this is how Bean's code looks like, right? So let me just zoom in a little bit to see it better. All right, so first thing I just install, right, Apache Bean with the GCP and pandas. So I install already. Then I just have to import some of the parameters I have. I'm importing beans and then pipeline options. And of course, I need to count number of transactions. That's why I have these count combine functions. And also I calculate the means, the average of it, so the means combine functions. So all these like SQL-like transactions are actually encoded into the function. So you don't have to write things yourself. Right? All you have to do is to define the boundary. Where do I chop off the data? And then where do I end the data? Right, so I'm doing this minute windows, second windows. They take it by the seconds, so you have to time 60 for the minutes, and then 60 times 60 for the hour. Here I'm defining like auxiliary classes. So you do have to define like Python classes for beans to kind of know what to do with the data, because all the data are coming in like byte stream. So you kind of have to convert it, and then say you want a timestamp into Unix, then you have to convert the function yourself. Right, they have built-in function, but I rather take it into my own hands so that I don't screw up the time zone and all. So I do that. So I convert the Unix time. This is pretty much the function to print the element info. So by default, they print like the bytes, right? So you want to do like a print functions. And I'm also doing things like composite key so that I know which data set is belong to which window, because I'm doing a sliding window, so I have a duplication of data. There's some overlap of it. So I'm doing that. So you can see it's pretty much very similar to JSON creation. So I'm not going to just reformatting all these things. And this is the sample data that I have. Right? So this is to show you how it works. So this is a dummy data. So dummy data itself has like transaction timestamps, customer ID, terminal ID, and the amount. Right, the same thing that we did on the PowerPoint slide. So all I have to do is to define the pipeline options. I'm going to do this batch also the local. Right, so I'm not going to touch anything on the cloud. Right? I'm just going to do it on my laptop. So I just have to define my runner is direct runner, which will run directly on my laptop. Right? And then I have to say, okay, I'm going to save the main session because they're going to do this parallel processing. And I do type check for all. Right? So you can also type check none. If you like to live life dangerously, you can put none, and then no one checks the type. So the thing is, just to create a pipeline, you just have to say pipeline, and then I create a dummy data by using bean.create. And then this is padu. Padu is like do function, basically, like partition and do. So you just do what you want to do. It's a custom Python function that you want to do, right? So just pass in. So in this case, I'm just printing out the data, right? So just now, I defined my data into an array, a list, and then I just pass the data here. Then I print them out from the bean pipeline. And it's print out exactly what I want to print out, right? So after I have the data inside the bean already, I can manipulate it in the way that I want, right? So this is where I start to do it. So one good thing about Bean is that you can break the pipeline into segments, and then you can reuse those pipelines. Right? So you can create like a branch, right? So one streaming data, and then you branch it out, or multiple sources coming into one. So you can combine this like that, right? So I created a source, which is just to create a dummy. And then from the source itself, I attach the timestamp, I create the time window. At the window info, I convert them to name tuple. So name tuple is like a better version of dictionary, and then just bring them out. So once you have this, I have like this row is actually a name tuple things that Bean did. So what I can do now is I can actually reference it by doing like item dot timestamp, item dot tie ID, things like that. Right, so this is how it looks like for the row. So once I get all the rows, as you can see, because I'm doing sliding window, there's a lot of overlaps here and there. It's kind of messy to look at, but If you're working with maybe like 4 rows, that's okay. If you're working with like 1 terabyte, you cannot sleep for the night. That's how kind of like gets you from the data side of things. Even like there's like 5 lines, there's a lot of data going up. So what I need to do now is to enrich my data source. So I already have all this name tuple conversion. Then I need to aggregate, right? So you have all the data that is laying out. All you need to do is press them in to get the count, to average, and other things, right? So this is where I do it. I group by customer ID, composite key, just by using bing.groupby. Then you define a composite key, right? And from here, how I do is, remember, I have to take 15 minutes, 30 minutes, and 60 minutes window, right? So instead of me taking 15, taking 30, and then taking 60, what I do is I take one shot of 60 minutes that I just chalk off, right? So instead of doing 3 reads, just do 1 read, and then I chalk them off. So it's kind of saved me in terms of I/O and the process. So that's how I kind of did, right? So for the 60 minutes, I just take everything in because my time block is 60. But for 30 minutes, I'm actually chopping off. So I remove the timestamps based on the period, and then if anything more than that, I chop off. I don't take it, right? So this is where I get the 30 minutes thing. So this is how it looks like. Let me just explain one of the record. So now we have the combined key with the composite key, and then we have a number of 15 minutes, 30 minutes, and 60 minutes. Also average and also a sum, right? So it is kind of hard to look at the results, but if you're working on it, you will really know it because you will dream about it at night. So that's pretty much how I did. And once I have one features, it doesn't end there because I have 3 other features to create. So I have to start creating more features, right? So this is for 60, and then this is another ones to filter out the duplicate results, right? Anything that is not into the format, I cannot do that. So I filter only, and then I record them out. And I also need to remove empty rows. So sometimes the customer doesn't do anything, maybe I did once for 60 minutes, and then I don't do anything for 15 minutes and 30 minutes because I only do it at the last minute. So you have 1 record for 60, but 0 records for the rest. So you kind of have to remove those rows as well. And then we have to reformat it so that people can see, right? Because I can't just put this kind of data into the database. The administrator will kill me. So I have to kind of like make it nice, put it into dictionary. So dictionary is like that, right? With the proper format of the decimal. So you have transaction ID, timestamp, customer ID, terminal ID, amount, which are all type stream now. And the rest like 1 and 10.0. So if there's anything that is count, it's integer. There's anything that's average and the sum is decimal, right? So I kind of do that as well. And then once I have it, this is the end results, right? So we have like 5 records. Now I have 5 records because I compress them by using combined functions. So during the process, there's a lot of readings, and cannot sleep at night. But after this was done, you're like, okay, I feel relieved because now I get some results, right? So you can easily compare it. And the good thing is, once this is done, usually if you write code, your dummy tool example is done. You still need to kind of like make it into proper format, right? Syntax, type hint, and all that. For this case, right, all I need to do, it was just to change this. So this is actually reading it directly from the streaming. So the data is actually streaming from the data store, like pops up, right? So we call it the data streaming pipeline, where I just try to read it from there. So this is exactly what I get it from the data, but this accurate data that's coming in from the terminal, right? So the transaction IDs and the timestamps, the customer IDs are no longer like 1 or 0 and all this anymore, but it's the real data that coming in. So all I need to do was, instead of putting in streaming false, I just say streaming true without changing any code. Then it will just start using that streaming functions to process it one by one. Right? So I can't run this here because it will just keep running on my laptop until I stopped it. But what I do is I want to run it on the data flow, which is on the server itself. And what I have to do is put all this thing into main.py in a way that package it. then I have to just change one thing. So all the functions are actually the same as we did initially. What I need to do is to change the runner into data flow. The rest is just the same, right? Of course, this project ID is from like, Google Cloud requirements and stuff. And then I can define number of workers I need. So if you set it to 2, it's parallel processing. If you set it to 10, there's a lot more things. Because if you set more, it's more expensive. So you have to kind of like, cater to what you want to do. All these pipelines are the same. I have the source, enrich resources, aggregating into rows and differentiating all the sums, count, 30 minutes, 15 minutes, and 60 minutes. The same thing for the results. I need to clean them up, and then I print them up, right? So I just put this into a Python file, which was saved into here, like main.py. So exactly whatever I just wrote there, it will write here, and then make it into a file. Then I have a requirement or Apache bin, which I just install it. All these packages, actually, by doing this, let me see. So by running the python.main, it will actually trigger. It knows exactly what you should do. When you run this thing, it will look at main, and it will upload this requirement directly to the cloud. So it should be running here. It will create a job here. Let me just do this. So you don't have to even like upload the file directly. You just run it from your Jupyter notebook, and it knows exactly where to upload it. So it will upload, and then it will start running this. And if you click into it, you will see all the steps that you wrote down here, right? So the first thing is read from pub/sub. You decode the byte into JSON array, attaching the timeline, sliding windows, adding window info, converting the name tuple. And here, I filter only some elements and then group by some of the keys, right? And also, I need to assign the key back and then merge the collection back. So you can see all your code visualized into simple steps. So if something went wrong, right, there will be like something wrong with this. There will be an error alert. So you know where to look at and which part is wrong. So at least this is pleasing to me than all the numbers and the code. So I like to do that. And I'm just kind of like printing out. So anything that you want to see, you can also see from the log as well. So now it's not printing any log, I think. Let me see, data sampling, no. Yeah, so that's pretty much about my talk. So if you notice the name, the title is beaming up into the flow. So you are just using beam, and then you're upping to the flow without uploading any source code at all. So we just run this main that you created, and then it knows exactly what to do, and we just create a job on the Cloud Console itself. Right, so if you have any questions, I'm happy to take them. Let me just go back to my presentation. Yep.
Hello.
Yeah.
Thank you for the talk. So I have like a couple of questions.
Okay.
The first one was, you mentioned in the challenges
Yep.
that accuracy was important, but
Yeah.
you didn't talk about it. So
Yeah. So how I did accuracy was important is, remember there was a final one, this. So now, currently I'm just printing it, but there should be a step to check for whatever you are doing, right? So how I compare this is with the stale data. So this is the streaming data, and it's coming in, that I can compare it the next day because I already have all the data for the data I want. So I will have a BigQuery database that is actually sitting in. So I average that database from that time. I will compare with the time from here. So if I'm doing a good job, I should match with the select statement from the SQL. So that's how kind of accurate you can do. Yeah, you can actually input that steps inside by using the functions. Right? Because I haven't set up the BigQuery database to store this thing. So, but it's additional cost, right? Everything you do kind of add up to it, but you can do that kind of thing as well.
And what happens if there was some mismatch? In that case, what would you have done?
So if there's mismatch in that case, I have to investigate, right? So there's no easy way around it. So one thing, what we do in machine learning is what we call a data drift measurement. So we want to measure whether the data that's coming in. So first thing first, we detect what's normal for this data, right? So for example, if a customer, they are purchasing maybe 3 items a day, and suddenly that customer purchase 100 items. That's not normal, right? So you should have alert before it happens. Yeah, something like that.
Okay.
So you kind of see what normal for the data, and you have like a dashboard that's measuring. So I think you can also see, I'm not sure, because this is just like, so you can see from here like how the data is coming in, what's the freshness, and how long do you take to process all the steps and all. And also there's some job metrics that you can define. So number of workers, some of the matrices, data freshness. So these are some of the indicators for you to kind of see what's going on in the pipeline. And if, like for example, sometimes you don't know the ground truth because even the company itself do not know what's the ground truth. This is where you start talking to, let's say, a consultants from that particular domain and say, oh, what's normal for you guys? And then we kind of adjust our ground truth if you're normal. Yeah.
Okay, thank you very much.
Nice, thank you.
Hello. Oh.
Hello.
So thank you for your talk. I know that Apache Beam was actually based on a couple of papers from Google, Fluent Java and something else.
Yeah.
So I wonder, like, what's the current Python support for it, and overall, like, now it's owned by Apache. So what's the current how active the repository is being maintained by whom, and what's the status?
So for the Apache Beam library is quite active. So they are currently what you did is the feature engineering, right? So there's no machine learning elements involved, although it was a machine learning project, right? So recently there was the shift from the community to have machine learning capability inside the pipeline. So they were like, we don't just want to do data engineering within the Beam ecosystem. We also want to have like machine learning capabilities. So I think about a few months ago, they integrated like GPU attachment to the pipeline. So you can actually create inference pipeline, training pipeline using the Beam. And one of our advocate, he's not from my team anymore, but he's like he's taking care of this Beam, so actively. So it's like his full-time job to take care of it. And I also know some of the people within Google who take on Apache Beam community building as their job. And they organize virtual meetup every now and then. You can follow them on Twitter. So I know some of them personally. I also gave a talk about this maybe 1 year ago. So the community is quite active, but from Google involvement, they are involving more around thought leadership and community building. Yeah.
Thank you.
This answer, yeah.
Thank you.
Any more?
Any other questions? Okay. This is the last question, please.
Okay, yeah.
Hi, the tool looks great. I heard about Beam, but never really used it. I have a question regarding to, seems like the pipeline stage is somehow quite resource heavy if you think about it. It's, imagine your upstream is some sort of message queue where we're talking about consolidating all the data, and if you apply some moving average on that, do you find difficulty on scaling at pipeline part, or it's supported already with some horizontal scaling?
I think there are a few ways to create that kind of like aggregation pipeline. So the one that I use is like the main combine functions or count combine functions. Those are actually type safe, parallel ready kind of functions because it's built in, right? And if you're writing, so things that you do sometimes if you want to customize, you do pardo, right? So pardo takes in any of the functions and then try to scale it up. And the way you write your code, it should be scalable, like it should be like something that can parallel process, right? It shouldn't be you have the output coming in from the first function and then you're waiting for it to happen in the next function. So you have to break it down your code in a way that is idempotent, can be rerun if you need it. And also when you process it, don't try to take in so many things at one go. Make it like, break it into like, for example, I'm doing every 1 minute. Don't wait, let's say, don't use Beam for something like, oh, I want to aggregate 1 day data. Right, you can use some other tools for that, but if you want to make it fast, make it independent from other tracks. So, and when you create it, let's say you can increase the max worker, that would actually they just take in the jobs and then try to scale it out. Yeah, I hope that answer it. Yeah. Okay, no more questions, right? So if you want to try, this is one of the kind of a free gift from me. Just scan it, you get like $1 kind of credits to enable Google Cloud. And okay, $1 is because you get all these things activated for you for free, right? So even though that's just $1, everything you are using from here is kind of free, okay? So, and yeah, this is actually our booth. So if you have questions, find me at the booth. This is some of the things. If you sign up, you get some free gift from the booth as well, right? And yeah, this is how you contact me if you have any questions, even after the talks. So with that, thank you so much for your time, and I hope you have a good day and a good session.
Thank you for your presentation. And audience want to see the QR code before QR code.
Before.
There are one try GCP.dev. Yeah. So if you want to try the data flow or something,
Yeah.
please scan this QR code. And thank you very much for your talk.
Thank you.
Please give a big round of applause to the speaker. If you have any questions and would like to talk to the speaker directly, please go to the hallway or open space. Speakers will be around, so we ask for your cooperation in not gathering around the stage.
Okay.
Thank you.
Thank you.
Lunchtime.
Thank you.
It just sounds bad.
Yeah, if you're fine, it's fine.
No. It's like the end of a cold.
So your screen will be displayed. So this small screen will corresponding to the main screen. So
That's so cool.
currently, so your desktop will share to the all over the world.
That's so cool.
Resolution, the screen.
I'll fix it.
Sorry.
So currently the signal come here but doesn't come there. So it doesn't come to the projector in the end. So we need to check the. Yeah. So this is the known issue, especially for Mac.
Oh, okay.
So we need to check we need to change the resolution for the monitor so that it can understand. 1080でしたっけ ?1080 でしたっけ
多分それ、OK。Yesterday I talked with my Mac and I maybe select this one. So.
Working with that resolution, which is specified right now. Yeah, so everything is red. It's not screen share mode.
Okay. So here. So Oh yeah, people can hear me just fine. Yeah, so if I sound like this, I sound normal.
Hello, everybody. Are we ready to start? If you want to tweet about this talk, please use the hashtag PyCon APAC_1. Now, we are going to start Nyaj-san talk. The title is Debugging and Troubleshooting Python Applications. Before the presentation, the speaker will read a statement as a microphone test. Please read over here this statement.
Just do a mic check.
Yes, this is the mic check. So please
Okay.
read.
So my name is Neeraj, and the talk title is like debugging and troubleshooting Python application. And the presentation will be in English, and the presentation materials will be published. And I agree to having my picture taken during the presentation, and I'll comply with the PyCon Japan Code of Conduct.
Thank you very much. Microphone test is okay. So the presentation time is 30 minutes, including questions and answers. Please welcome Nyaj-san with applause.
Hello, everyone. So this talk is about debugging and troubleshooting Python applications. We'll be seeing like what are the best practices and how we can leverage the observability eventually to help us like making our processes more smoother. And I'm Neeraj. I'm a software consultant and a generative artist. And I am co-founder of a climate management company called Vivid Climate, where we are trying to do like carbon emissions and ESG marketing and all in the Asian market. So to begin the talk, we all know like as a developer, we strive for performance and not just like a bug-free code, but like continuous monitoring of systems in both monolithic and microservices applications. So let's consider like we have a new product, like we are building a new company or a new startup kind of a thing, where what you're doing is like simply we're fetching some information from a banking API and then just like displaying it to the users or something. Let's consider it's like the basic MVP of a product, then that's going to be a monolithic application. And over there, let's see like how we can use one of the more like the core practices that we can aid in maintaining the code quality, which is the logging. So we all know like logging provides a window into the operation of any kind of application. And it doesn't just like helps us diagnose issues, but also understand the performance metrics. So in Python, we can simply use the robust logging module, which we can see like over here. If, for example, this is a straightforward function, which is a fetch function, which asynchronously fetches some information from the Pleo API. And for example, we're taking some banking cards information from this API. We can simply call the logging.error function or logging.info by just like passing the statements or the response status. But like if we run this up, we'll get nothing. Any idea like why? So there's a thing like you have to do some configurations for logging in Python. And what we're doing here is like we're just like providing a version and some formatters by way we're saying like this is going to be a logging formatters and this is going to be a format for the date and time and name. And then we provide two handlers over here, which is one is the console and one is the file handler. The console one is just doing like all the data should be coming up in a stream and should be logged into the console what we are using. And then another one is a file one, which just takes your file, your output and just like saves it to the file. Here is like app.log. And if we just like use it and now run the function, we'll get the output, which is something like this, which is like a pretty simple minimal like output for like, it says the error, it says the info and all. The second thing is like we have log levels in Python. Like every single log level is associated with a value associated with it, like not set, debug, info and all. And what we also can do is like we can create our own log levels in Python. Like for example, we want to have something like a PyCon level, which is being associated with a value of 15, which is a little ahead of like the debug value. How we can do this is like we create like a variable called PyCon level, which has the value of 15, a little more than the debug one, so that like it's always ahead of debug. And then we create a new PyCon method. What it's doing, it's like it allows logging at the PyCon level. And then we just like pass it to the logger function, which is the global function in Python. And then we are doing the similar configurations we just did in the past slides. Like we just adding a handler, a stream handler, and then just like calling the loggers. So now what's happening is like, if we now call something like self.logger.pycon, it will log the issue at the PyCon level. And one major issue is like, we don't always want something like a plain line of logs. We also want something, a structured logs, like something which is in the format of JSON or something. So what you can use is like, there's a library called structlog, which is like quite robust in Python. And it provides you with a structured JSON formatted like logs for your applications. How to use it, it's like, there are like a couple of configurations you have to do. So it normally takes one of the most important, which is the processors, what are the chains of callables, and through which your log entries are processed. And what we're doing is like, we are calling the filter by level, which is gonna take all the logs by level. Then we add the logger name. Then we add the log levels, which we are using. Similarly, we're using the positional arguments formatter, which is gonna be formatting our entire application. And if it's not clear what I'm talking about, there's another slide, which is gonna be, yeah. So you'll see like the positional arguments formatter. What it's gonna do is like, it's useful to have these placeholders, and it's gonna add those placeholders to your log like the log files. And then we add your timestamps. And yeah, it's pretty much the same. Like you format it, you unicode it, and you just like add a JSON render, which is gonna convert your log files into a JSON, formatted JSON file. And if you run this, you get the structured logs. But the major issue is like when you're working with big applications, you have logs like this, like you have thousands of log files. But what you actually want is like these logs, like you want a specific logs. So over there, we don't prefer using something like a localized version of log files. You prefer something going as a centralized logging. You can use anything like a ELK stack or something. For simplicity, I'm just using the better stack platform. You just like call the logtail handler over here. You just pass it and you just call it. It's the same thing how your logging works in Python. It just like adds all the log files in a more structured way in the better stack dashboard, where you can get all these, the file names, the function, the methods. It also creates your process IDs, which is unique. And yeah, it just like also tells you the log level which you're working on and the severity level. Then the second thing is like debugging. So we just like added some logging to applications, and now what happens is like a bug came into a monolithic app like the banking app we're working on. How we can fix it? So there's like a famous quote by Arthur Conan Doyle, which says like, when you have eliminated the possible, whatever remains, however improbable, must be the truth. So when you have eliminated most of the impossible bugs, like whatever remains, no matter what, it's gonna be the bug which is causing the issue. So a quick definition is like, is the identification. This is where like all our developers just like find the anomalies and bugs which might be hindering the code execution. Then we isolate the specific section, and by adding the breakpoints and everything, and then when we find the resolution. But the problem is, most of the developers do debugging like this: print, 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 print. A lot of print statements. I mean, almost everyone does that. But like the problem is like when you're working with a big function which has like thousands of nested functions just like calling each other, it's not gonna work, because it's gonna give you a file which looks like this, but like this is just a very simple function. But like if you have like hundreds and thousands of nested like print statements, it's gonna be a chaos. So over there, what you can use is like we can make use of the Python debuggers. So there are two types of debuggers. One is your command line and the IDE debugger. So the command line is basically PDB, the Python debugger, which is the inbuilt in the standard library, and the IPDB, which we'll be seeing, is the interactive version of it. It can be used in your Jupyter Notebook files and all. PyDB is another one, which is a graphical representation of the same thing. It gives you graphs and all. And the IDB debuggers are basically more or less like platform specific. VS Code has its own debugger, PyCharm will have its own, and Wing will have its own. So how to use IPDB is pretty straightforward. You just like import the IPDB and just like call the IPDB set trace. It will pause all the executions and allow you to inspect the current state of the program. And the commands is going to be pretty simple. Like you have something like a next, which is n. It's going to continue the execution until the next line is reached, and then it returns the statement. You have the continue, which continues the execution only until some sort of a breakpoint you have added has been reached. And you have quit, you just want to quit the debugger. S is like step-by-step execution, you just want to check. Print is going to print, and A is another one which is going to print all the values and the variables of that specific functions or the callable. And R is basically your return, which is going to continue the execution until the current function is returned. And if you run this, you'll see like the script hits the breakpoint and pause the execution when the debugger reaches the error statement. And here in case we can see like it's the 401 error which is coming from the Pleo API, which says like, hey, we know this like we are unauthorized, maybe the bearer tokens are incorrect, and yeah, that's where it's gonna raise an exception, and that's how we're gonna debug our applications. Once we are done with the debugging, the major problem which we find is like how we profile our code, where exactly the CPU usage is going, and what is the memory usage is happening. Because what is happening is like most of the issues are happening here because of the memory usage and all. While debuggers are like indispensable for debugging and fixing your bugs, what we also want to do is like we also want to make sure the resource utilization is done correctly. So this is where we'll be using the profilers in Python. So profilers are basically more or less like 5 functions. It helps you find the bottlenecks, where exactly the most time is being consumed, and optimization, like how we can optimize our current code in production, and what are the, more or less like what are the functions which are taking the maximum memory and where is this memory being allocated. The function calls is where you examine the frequency of the time spent on every single function call. And it also works with the multi-threading and all. I mean, if you're working with the stacks and like the Python stacks, like continuous stacks, you might not use the debuggers or profilers. You can simply use something like PyStack. So it's the P stack, but not for specifically for Python. So, but what do you look at profilers? Python has a lot of profilers. Like the core inbuilt profilers are called C profile and the profile, but these profile has some issues. Like C profile is a robust deterministic profiler, but the problem is like it adds a decent amount of overhead to your code. Like you don't want that. And if you use the other one, the profile, it's a pure Python profiler, but the only problem is it has a high overhead when it's run. So what exactly we're looking for in profilers is like lower overhead, and something is like it should not be just it depends on the use case. It could be function-based, it could be line-based. So a function-based profiler is basically which gives you the profiling of your entire function instead of just going line by line. And your line profiler is basically which just like gives you every single line, like where exactly this call is happening. So we'll be talking about 2 major profilers here, which is C profile and Scalene. So C profile is something which majority of the Python developers use these days, and it's very reliable, but the only problem is like the overhead. And there's a new profiler called Scalene, which doesn't just helps you find the CPU usage and all, it also helps you do the memory profiler. Because apart from this Scalene, you have memory profiler, which again adds a lot of overhead. So what's happening here is like, also one more thing, like there are two types of profilers. One is called the tracing profilers, and the second one section is called the sampling one. So what is happening in the tracing profilers is like we're intercepting every single request, every single call, every single return and exemption in your code. And what they're doing is like they're tracing the execution of every single line or a function call, either it's happening in your Python file or the native code in C. And the second one is your sampling profilers, which work by periodically checking for all your stacks in your program and at regular intervals. And instead of tracking your every single function call, because we don't want sometimes to just add an extra overhead, so that we sometimes prefer sampling profilers. But the thing with Scalene is like it does both. It's doing both the function base, the line base, the GPU, the CPU, the memory base, and everything. And the good thing about it is like the overhead it's adding, it's a little more than the people file stat or the PySpy, but it's like very comparatively high, but like way too low than any other YAPI, yet another Python profiler or profile in Python. So C profile is another built-in profiler in Python, and it provides a detailed statistics on function call, counts, and durations. And to call it, it's pretty straightforward. You just call the C profile, and you just like let it run. Whatever you just pass the function, and it will give you the output. So if we see over here, we have an example. We have a function which called get expenses, which gets you all the expenses from the API. And you have your another function which saves those expenses to your file. And these functions are calling the helper function, which is called fetch, and the last month's date range. So what is happening is like one function is calling the other two functions and one helper function. So if we want to profile this code, like where exactly these memory leaks and everything is happening, we can just call the cprofile.run helper. This is a little different from the example I showed before, because here we are using the cprofile as a context manager kind of a fashion thing. And since Python's cprofile isn't inherently asynchronous, and if you see like we have the function as an asynchronous function, that's why we are using the asyncio event loop here. That's why this function is like with cprofile.profile as PR, and then we just like run the helper function. And why we're doing this is like, because we also want to start this, what do you call it, the profiler, and we also want to close it. So that's why in Python, if you use this, the context manager, it's gonna give you like behind the scenes __ enter __ exit functions, and they will start and stop the profiler on their own. And if you just like run on your command line, you will see it gives you all the cumulative time, total time, and here we are sorting it on the basis of the cumulative time. But there's one more issue with these kind of profilers is, so for example, here it's saying like the majority of the time is taken by, for example, app.py or plio.py, but that's something we don't want. We actually want like where exactly in the function is those extra copying is happening or extra memory is being allocated. So we'll talk about this in Scalene, but like there's another tool which is like, because this is something which is very hard to understand. Like it's like you see it, you have to figure out like, okay, there are like 50 different calls are happening, and which one is taking what amount of time. So you can make use of a library called SnakeWiz, which is gonna take those JSON, the JSON output, and just like put it into an HTML file. And if you just like run it, it will be giving you an output in a HTML file where you will be, you can just like click, zoom in, zoom out, and see like, okay, plio.file was using this amount of time, and what are the native functions which are being called by this function is taking the time. And that brings us to Scalene. So Scalene is another Python profiler, but the only good thing is like it doesn't just like calculate the CPU time and all, it also calculates your GPU time, the memory allocations, the memory usage, and everything. And using of Scalene was a little problematic initially, but like now it's pretty straightforward. You just like call Scalene, your program, and what it does is like it creates two files. One is your JSON file with all these values, which it calculates in real time, and another HTML file, which it runs in the browser. So what's happening here is like, if you see, it's doing a line profile of the functions, and it's saying like, okay, this is the amount of memory it's being using. The X amount of memory is being used by the Python on the system, and the Y amount on the right-hand side, it's being used by the native. The native calls it's doing your C and all. And it also gives you the memory activity, like how much memory it's being utilized by in this process. Another good thing is like it also now adds a feature of using the GPT API. So if you just like put your open this GPT-4 API keys, and it will automatically gives you the solutions to these values. Like if you find like there's a bottleneck, why this is copying so much, why there's a memory like leak happening, or like it's taking a lot of memory or CPU usage, it will tell you like how to fix it as well. And one important thing, which is a quite unique thing, is like copy function, the copy feature. What it's doing is like, if you know, like in Python, when you make a call, it makes a call to the native functions. And what's happening is like sometimes the way you have written your function, you just send some value, and meanwhile it's processing it, you takes it back and copy into your Python code and then sends it back to it. So this back and forth thing is just like copying a lot of values, which is just adding to your memory and all. So this is one thing which none of the other profilers are doing right now, and Scalene is telling you like how you can fix this as well. So it's all good. Like if we did our logging, we did our debugging, we did our profiling, and it works very well. Like in our monolithic application, we have our payments, we have product catalog, customers, and everything. But what happens is like once you start getting a lot of customers, multiple people will be working on the same code base. And then what's going to happen is like it's going to be fault isolation. So if there's a single fault, it's very hard to isolate that error, and the entire application will be burned away. And the third thing is like it will be tight coupling. Like code becomes very tight coupled, and it makes very difficult to work on it. And eventually it becomes a chaos. Like the application gets stuck. So let's say like we figured this thing out and we just moved to microservices, where we just like split our code-based services into different services. Every 7 services talking to a different database. And it works fine. If you normally log it out, it works completely fine. Debug is also fine. Profiling is fine. But when these services starts talking to each other, then it's an issue, because traditional logging and all these things may have the capability to provide some sort of insights, but like when this kind of scenario happens, we have to go to something which is more standardized and which has a holistic understanding of the system state, like the telemetry data. So that brings us to something called observability. So observability is something where we use the functions or request telemetry data and then see like what's happening behind the scenes. So quickly we'll see like what are the 3 pillars of observability. These are the tracing, the logging, and the metrics. So the logging basically captures your discrete events. It's the same thing. Logging will be done the same way we have been doing in the previous slides, which will be offering a detailed record of what exactly happened and all these rich contextual informations we're getting. The second thing is your metrics, which is new for us. Like now we also want to see like what are the quantitative view of the system we are getting, like the system health, or the health checks in microservices, what are the CPU usage, how we can show the aggregated data usage, error rates and all. So that's the second pillar. And to have a proper observability system, the most important is called tracing. We also want to know like what's the journey of these requests, because for example, we know like our system breaks because in this functions because of this call, but we don't even know like why it's happening. So in order to understand that, we need to pass a trace in the request so that like every single step should be visible to us and we can know like what exactly is happening, what is causing the latency, the bottlenecks over there. And to use these, because if you'll see like different developers are using different kind of backends, different kind of languages, and we want to use a standardized way of passing those telemetry data from your applications to your backend services, like if you're using Prometheus or something like Grafana where you can send your information, you want a standardized way. So previously, there used to be open tracing and open consensus for tracing data and your metrics data, but those just like combine into open telemetry. So it's a standardized way where it allows you to use their SDKs and APIs by which you can basically instrument your entire applications using the OTel or OLTP. And what's happening is like they have an exporters which helps you send all the information to the backend of your choice. That's the exact thing we are looking for because we want a standardized way over here. And it's quite flexible, like in terms of context propagation, how your values are going. Be it like if you want to use something like W3C or a B3 propagation, it works with everything. And then there is a collector which sends all the values. When you send all the values to the collectors, either it's coming from your application using the SDK, or it's coming from a Kubernetes mesh like Istio or something. And you use those values from the collectors and send it to your backend of choice. So to understand this, let's say this is our request. Like we have a source, and it's sending a request to the service A, then it's calling service B, D, C, D, and E. And we'll see is like at every single step, the time taken is like, for example, at service A, it's taking 100 microseconds, and at B, it's 70 milliseconds, and at C, it's like 24 milliseconds. So this is where we feel like, oh, okay, something's wrong, why it's taking so long? And eventually what happens is like, somehow it crashed. So how we are able to see this, it's because of the spans and traces. So a span is basically, when you send a request, you have something like how much time it's taking and what is the next value it's being calling. So for example, if you see there's a service A which is calling B is calling C and D, and A is also calling E. So how it's working is like, span A starts the process, it takes some X amount of time, and then the span B starts, and meanwhile span B is completing, maybe it's an asynchronous call, span C starts working, and span D also starts working, and when these finishes, it comes back and span E starts to work. So these are the spans, and these are the smallest unit in our telemetry data. It could be anything, like an API call is a span, a database request is a span. So anything from as small as a database request to anything like saving something in the cloud can be a span. And when you combine all these span all together, you get a trace. Like a trace is basically a collection of all your spans happening, but the only important thing is like the trace ID remains the same. It gives you a unique ID so that you can use that value for the specific request, and that's being stored in the systems. And whenever something happens, you can just like look up to the trace ID, and you can figure out like, okay, this is exactly where my system just broke up, and that's where I need to see like what's happening. So we'll see in the next slides like how we can use this telemetry data and send it to Grafana to visualize everything and see like how we can see the logs and the traces over there. And something we all just discussed is called the context, like how these values are being sent to the OTel collectors. It's like you have a span ID, and every trace will have every span will have its own ID, but the trace ID will be the same for the entire spans, which is in a single request. And then you have the parent ID. So if a span is if a span is calling another one, that becomes the parent ID, the parent span, and the child becomes a child span in telemetry data. And then you have the trace flags. This is just to add some sort of additional information about the trace. And you have the trace data, which is just vendor specific. It depends on what kind of vendor you're using, Neural Lake, Grafana, or whatever you're working with. So if you're using the OTel, like the OpenTelemetry with Jaeger, so Jaeger is basically to help you visualize all your tracing information. You can simply add the Jaeger image in your Docker file, the Docker Compose, add the ports which will be listening to it. And the first step will be in your code will be to set up a tracing to initialize the trace providers. And then you add a Jaeger exporter, which is going to be coming from the OpenTelemetry SDK. So this will help us monitor and troubleshoot the microservices-based distributed system we'll be using to send those telemetry data. And once it's being created, we have to connect the trace provider to the exporter using the batch span processor. And this is again coming from the SDK. And then eventually, once everything has been connected, all the pipelines are set, we just call the fast API instrumentation, so that like a API or the function is being instrumented to collect those tracing data. And once we run it, all these values, whenever we send a request, will be called in the Jaeger dashboard. And we can see like every single request can be seen over here. And if you click on it, you will be able to see like, okay, so this request had a receive call, an HTTP call, and there is another send call and how much time it's taking and when it's starting up. And if you click on it, you'll also see like the detailed information, like what's the HTTP host, what's the URL, what's the target, what's the port number which is being called, the peer IP and everything. So you get to see like where exactly the majority of the time was taken in my request. So this is like one part of it, like the tracing. And which brings us back to OpenTelemetry, like it's not just traces, right? So if you see this kind of a graphical representation, we see like there's a lot of information coming in from maybe microservices using our SDKs, or something like a shared infrastructure from Kubernetes or proxies or cloud services like GCP, AWS. These values go to the OTel collector, which then exports it to your favorite choice of front ends, maybe New Relic you're using, Grafana, or whatever you're using. And if you try to use with the OTel with Prometheus, or Loki for your logs, your Grafana is for your dashboard, Tempo is for your traces, which is provided by Grafana, and Prometheus is for your metrics. So you will see a dashboard like this. I mean, you can always tweak those values, because this is just your Grafana JSON values, whatever exactly the metrics you want to call. And here you'll see like a system called the expenses, which you have been calling since the start of the presentation. And it had like 2 exceptions and 2 calls were done. Both of them failed. And why they failed or why they passed, if you go to the next slide, we can see like we can change the value, like what exactly is this value coming from. If it's the traces value coming from Tempo, we can see, oh, there's a list of traces which happen in all the requests. We figure out, okay, this is the trace we are working with, and the trace has a specific unique ID. We click on it, we see, okay, these were the traces. And for example, here, this request passed. It's again a GET request to the expenses. And if you want to see some logs, you can also see them by clicking on the log button, or you can just simply change the Tempo to Loki, and you will be able to see like, okay, the logs which you were making initially in the applications can be now traced back to a specific trace ID. So we don't have to just like search for the log files and just say like, or maybe if you're on a Linux system or something, you just tail it up. And yeah, so this is a much better approach when you're working with big microservices application. And similarly, you can also get the Prometheus data in the Prometheus dashboard. And yeah, that's pretty much it. This is how you can leverage your observability and debugging to code faster and better. Thank you. So I think we have a few more minutes, so if you have any questions.
Can I ask you a slide later?
Oh yeah, so I'm really sorry. I just have to create a link for this. So I'll create it and I'll just like send it to. I can just like you guys can just like check my Twitter. I'll just like post it over there. I just like forgot to make a copy of it and just like add a URL for this.
Thanks for the talk. Just one comment about, there's one slide where you just make a joke of it. It's like everybody uses debug print. So I found out yesterday there's something called ice cream.
There's something called ice cream, which is better than printf.
Better than print, yes. You should still use a debugger, but if you really have to, use ice cream instead of print.
Yeah, true. Thank you so much. Oh yeah.
Thank you for your talk. You mentioned profiling and covered various tools you can use for that. Mm-hmm. Do you think profiling is something that a software engineer should care about, or is that something that should come with the platform? Like Grafana provides something like Pyroscope, I believe, that does continuous profiling on the servers, and you can have your flame graphs along with your metrics, traces, and logs in Grafana.
But those are happening in the production, right? Like when your app is in the production.
Yes, that's true.
But like we as a developer also have to take care of like the system or the functions which are being called are actually working before just like pushing them into production so that like the father can just pick it up and just like profile it for us. No more questions? All right then, thank you so much for joining, guys. See you later.
Thank you very much your presentation. And next talk will start 2:10. So please change room or prepare next talk. Thank you. Party announcement about today's party. Party registration is now open. If you have a party ticket, please come to the registration desk by 17:40, PM 5:40 to get a wristband. So please come to the registration desk by 5:40 to get a party wristband. Attending the party requires you to have a wristband. Thank you.
一応日本語でも案内しておきます。パーティーの受付ただいま開始しております。パーティーに参加される皆様、リストバンドをつけていただく必要がございますので、受付までお時間あるときに取りに行っていただくようお願いいたします。
now, thank you for waiting. And now, presentation setup. Okay, thank you. Now, we are going to start Philip San's presentation. The title is Unleashing the Power of LiDAR with Python. Before the presentation, the speaker will read a statement as a microphone test. Please read.
My name is Philip Andrespina. The title of my talk is Unleashing the Power of LiDAR with Python. My presentation will be in English. The presentation materials are in English. I will publish the presentation materials, and I agree to having my picture taken during my presentation. I will comply with PyConjp Code of Conduct.
Thank you. Micro test is okay. So please start your talk. Please welcome Philip San with applause.
Thank you, everyone. So once again, my name is Philip Andrespina. So I am currently a master's student, particularly Master's in Computer Applications in Mindanao State University Iligan Institute of Technology in the Philippines. So I was, before I came back to the academe part, I was a Python engineer. I specialize in machine learning and data analytics. I work for small to mid-level startups remotely in the US. So that's where I got lucky with an opportunity to work before for a company that worked on LiDAR, which I applied to my current master's, and which I will share a bit to you so I can share my knowledge. Okay, start. Okay, so according to Grand View Research, so the global digital twin market size was estimated at 11.13 billion in 2022, and is projected to grow at a compound annual growth of CAGR of 37.5% from 2023 to 2030. So digital twin technology is gaining traction owing to its potential to bridge the gap between physical and virtual worlds. So imagine if you can take part by getting started with it in Python. Basically, it's becoming a trend. It's being a popular path as you go being a developer, especially that there are very diverse ways that as a developer you can take your career into. So this is an introduction of how you can get started with LiDAR, since that's the opportunity presented to us by Python to make things simpler and more versatile. So we'll be having these guide questions as we go through our presentation. So first, we'll be evaluating what is LiDAR and what's its application and use cases, and what is point cloud data, and how do you use Python to leverage it to easily master interacting with LiDAR data and making applications out of it, and what are possible but cool data interactions that you can do with it. Okay. So first we need to understand what is LiDAR technology. So LiDAR, in short for light detection and ranging, by definition, is a cutting-edge remote sensing technique that harnesses pulsed laser light to precisely measure distances to the Earth's surface. In essence, LiDAR operates by emitting laser pulses that bounces off objects in the physical world and returns it to the sensor, and the sensor analyzes the distance and timing, and then of the reflected light, and stores that as data, as point cloud data, which I will be discussing later on. So as you can see in the diagram, so that is a drone scanning a whole field of a location, and then getting that data back to the sensor itself. So some of its most of its applications are in forestry, agricultural, GIS, global information system surveys, and mining. So and there's also modern use cases such as autonomous vehicles where everything is viewed on live. So as you can see, there are lots of applications in LiDAR that we can take our development into. So the question is the integration that comes with it, so we can take advantage of Python. So in my experience when I work in LiDAR, so MATLAB was mostly used. So that's when I came with the question, how much if I could do this with Python? So I can do things my way, and I can integrate it with my own skill set, being a Python backend developer. So as you can see, there are lots of data use cases, like for example in farming, like they're being used like to identify the condition of the plants. For forestries, like to identify, let's say, the CO2 emissions, the oxygen. So basically, for like disaster and prevention stuff. And then there's the general GIS survey for like for just general information for the public, especially in transportation, something like that. So my talk will be focusing more on the GIS part, global information system, since for autonomous vehicles, we would need large amount of data for that. Unfortunately, the internet is a bit slow. So most of this data can be taken by this hardware. So mostly drones with large sensors, which can be very expensive. But that's why we took some data from open source sources, and we also have those camera-looking tripods. So those are not cameras, but they are like they are LiDAR sensors which takes geographical data on the road. So for autonomous vehicles, so these are like it's attached to like the vehicles themselves. So I don't know how it looks like. So going to the data collected by these LiDAR systems. So they are called point clouds. So point cloud data is our digital representation of our physical world. So reality is transformed into virtual 3D landscape by different points altogether. So it's a snapshot of environment by the 3D scanning tools. So what you can see here is it's a snapshot of pre-Kumamoto earthquake, so in April 16, 2016. So the reason why there are only few open source is because like it's almost like a treasure to get this to get this kind of imaging. So so this is my own setup. Since I cannot access it, I found a way to access. I just connected to my PC at home. So let me see if it can move. So as you can see there, it's lagging a bit. Yeah. So as you can see there, it's 3D. So it's this is a point cloud data, how it looks like. So when you enter that data, you will be shown all the points all together. And usually the one that takes the data labels it at the same time, like what we call in our place we call it like the pilot taking, or if we have someone to annotate the data from the LiDAR that it has been taken on. So as you can see, sorry, it's a bit like. As you can see, it's a picture. It's a LiDAR representation of a mountain together with some houses below. So I think this is the Kumamoto one that I showed you earlier. So imagine you could take this data. Let's say you would like to prevent some disasters. You want to see the geographical of it. So in order to do that, you have to manipulate these points like a Python engineer would do, right? So if we can do that in MATLAB in other languages, how much more if we do it in Python, which is our comfortable language? So luckily, there are tools available for us in Python these days. So what are the challenges when we are processing cloud data usually? So the data volume. So managing and storing all of this point cloud data set is often millions and billions of points. So it can be time consuming, and also hardware, a regular home setup might not be able to take it all together. So what happens usually is that this is being subsampled, which I will explain earlier, in order for that data to be manipulated on, so that as developers we're able to take that data and then manipulate it in order to get our own what we want to find out on the data, what our research is. Let's say we want to research on trees, or we want to research on the ground. So basically, you can do both as long as. Yeah. And data quality, ensuring accuracy and quality through calibration and noise reduction. So this is just to make your development easier. Data registration, precisely aligning multiple point clouds for seamless integration. So it is a challenge because it is hard to piece all together, especially, for example, you're using airborne LiDAR sensors. So in order for you to piece them together, it could be prove a challenge, and as a developer, it is almost out of your reach until you get that data. So it's up to you if you can find a solution for it or not. So the feature extraction part. So this is where our main role comes in. So we are trying to extract this meaningful data, like trees, like structures, buildings, from all of this LiDAR data, and we try to label them. If they don't have any label, we can annotate them. If we don't have someone to annotate, we can modify that data. So we can apply some algorithms so that we can show we can have a certain idea on where are the trees, where are the crowns of the trees. So we can separate all of those and then make our own calculation based on it. So how are we tackling these challenges? So subsampling, as I explained earlier, so we reduce the memory strain by the computer, because having home setups, it is difficult to work on like billions of data points. So we only have those representative portions, so just enough for us to take shape of that point cloud data that we have. And then next is noise removal. So noise removal consists of either reduction. So either we reduce our data so that we can have a minimum amount of what we need, or we can normalize our data so that we have less of what we can work on. And then block or chunking process. So we break down these data sets into smaller blocks to conserve memory. Let's say the pre-Kamomoto data set is like a very large data set. So we want only to take a portion of that. For example, we only want to research about, let's say, the carbon dioxide sequestration of the trees there. So if that's what will happen, so we only need the trees, right? So we put that into a chunking process so that it would be, it could make it easier for us as developers, so we can comfortably develop. So this is where Python comes in. So Python's extensive data manipulation libraries like NumPy make natural choice for subsampling. And then Python's rich ecosystem includes powerful signal processing libraries such as SciPy, which simplifies noise removal. There are also other deep learning alternatives that we can use for it. And also, using Python can divide large data sets into manageable blocks and chunks, making it versatile choice for handling memory limitations and creating organized workflow. So, Python in its Philippine data processing, its appeal is in its simplicity, readability, and wealth of libraries that make it a prime choice for newcomers and seasoned developers alike. These libraries empower users to efficiently process LiDAR data from acquisition to analysis and visualization, making Python accessible and versatile tool for its technology. So as you can see in that simple line, just in that simple line, it is able to read the last file. So a last file is like a point cloud file. It's one of the simplest form. So in a Python import, it is a sample of it where you where you read it, take the points, and then add it to a visualizer. So I will show you how it works later on. So these are the important libraries when you deal with LiDAR in Python. So LastPy, so it's a library for manipulating data in last format. There are other formats that are ideal, but last is the most easiest way to start as a beginner. And then PDAL, so versatile point cloud data processing. So for various data manipulation, so it's the same. It's a bit similar, but for certain use cases. And Open3D, this is a very robust library for visualization. So, and there's also PyLiDAR, which is where you can manipulate data and at the same time visualize. So what we'll be using for today is LastPy and Open3D. So we can make our demo lighter, given that I only have my laptop right now. So let's try having a trees airborne LiDAR data. So we will be going through just 3 steps, like simple step. We load the point cloud samples, we subsample, we noise reduct, and we chunk. And then we do our LiDAR segmentation. So this time, since we're going through, we have airborne LiDAR data. So let's say that we want to know like about the diameter of the trees. So basically below the crowns are the trunks, right? So we want to know the diameter of those. Then let's say we want to apply that to the whole mountain so that we can get a visualization of how it would look like, how thick the trunks of the trees in a wider scale. So first we need to load our sample. So hold on. So small. Okay, I already have it in place. So I have 3 functions here. I already separated into functions for easy readability. So I have a function to read the last file. I have the function that I want to compute the diameter of the trees. Also, I have the downsampling function. So given those functions, sorry. Let me see how I can. Let me go back first. I haven't presented for a while. Tools, Windows. Zoom in. 200%. 125. Is that bigger? Okay. Thank you. So we have the read, again, we have the read last file. So as you can see, I'm using LastPy to read, and then I'm using NumPy VStack to get, because point cloud data have our X, Y, and Z axis. So as you can see in my sample, so I see below. So those points are being taken into NumPy and converted into last points. And then the compute diameter, it computes the distances, I forgot the paper about this, but basically computes the distances between the trunk and before the crown. And then based on that, categorize it based on the points, the cluster of points in that area. And then we have the downsample. So I'm using a voxel downsample from LastPy also. So here we have last points. We can easily declare it and then send our last file. And then point cloud, we declare our Open3D visualization. And then once we got that, we take that last points that we read into vector 3D vector function in Open3D utility, and then declare this as points, and then we visualize it. using visualization.draw geometries function. So let's try to run it first and see that part. So it didn't detect my video card. Usually, if you have a good GPU, you can run this faster. Okay. So as you can see, I already chunked this part because it's heavy. Okay. So these trees are part of that large data set I've shown you that is running on my local PC that I connected at home. If you enter that, it's just a general visualization of the trees inside. So even how noisy do you think this data is, you would still be able to see the trunks that you want to target, right? So those are trunks, and there's the ground. Yeah, I think I removed the ground already. So usually, I think I'll show you the one that has the ground earlier. So usually there's the ground there, but I already removed that with another function that I will introduce to you later. So what we want to do is to get the to categorize the diameter of all of this by taking this small chunk of data, and then take that into apply this entire script into the entire Kumamoto data set that we have. So slow. So I'm going to close this. So this will be downsampled. So in the downsample cloud, so there's a downsample function, and then basically it will just take off the unnecessary points that I need. So the clusters within the clusters. So this is the subsampled one. As you can see, I can play with it faster. It's faster because it's easier to move. That way, you would, as a developer, you'd be able to easily manipulate it also, and then it wouldn't strain much of your computer's memory. You can also inspect things faster. Okay. So after we downsample this one, what we want to do is apply the segmentation that we want. Okay, let's see. So in order to apply the segmentation, we have our DBH. We have our DBH calculation. Hold on. So let's start at the first. So we have the point cloud. We have the points. We have the we already downsampled it. So we initialize the color. So the color that we saw earlier are the default ones. So it will show us like a heat map or something. But we want to color it in order for these categories. So in order we count the clusters into a DBH list, and as we compute the diameter and append it to a list. So basically we get a points of points of this point cloud data that would have the diameter at breast height. Diameter at breast height are the diameter of the tree. And then we normalize it as because we want to reduce the noise. And then we color it according to what we want to color it as it gets from the smaller one to the bigger ones. And assign it to the colors of the cloud depending on the downsampled point cloud indicator. And then visualize it with Open3D. So let's run it this one segment. So it's running a bit slower than the usual because it's already doing the segmenting at the same time. So I already chunked that up, so it shouldn't take that much time. processing. Yeah, I should have. Okay, so while it's processing, let's move to the next slides. I'll show you the output later. So let's try as we wait for that output. Let's try another example problem. So let's try a wider scope, but smaller amount of point cloud. So we initialize the point cloud data, and we segment from ground to non-ground, and then we segment it. We segment it or classify depending on its depending on the formula that you want to add to it. Okay, so it popped up already. So as you can see here, I categorize each tree to be red depending on the intensity of its diameter. So as we go closer, let's see if there are other colors, if there's any outlier. So there are certain stems that are blue, but most of it is red, maybe due to the voxel size. As you can see, like the points are already normalized and noise is reduced. Otherwise, like this branch would look like would have much point cloud data inside. So if you then apply this to a bigger scope of data, you would then be able to get a more of a variety, and also as you increase the size of your data, you should be able to get more diversity on the intensity of the dBH that you want to achieve. So as you can see here, we segment ground from non-ground and segment and classify. So this is identifying the landing points. So basically, in order your use case is to find the landing points, like for a helicopter or something, like for search and rescue or something. So let's say in a mountain like that, you segment, you take off the ground, and then you segment or classify. So let's try another example. Okay, I only have 10 minutes left. Okay. Okay, I'll just proceed. The other example was just taking the ground from the visualization that you saw earlier. So how does blocking works? So you have an input file, which is a last file in a chunks. So if chunk has data, you go to the pre-processing step, which is the normalization, the noise reduction, what did I forget? The reduction, because you want your data to be lighter as possible. And then you segment it using SciPy. I used SciPy earlier to get the dBH formula. So depending on the paper. So let's say that in the paper you saw a paper about getting the dBH. You apply it, you cluster it. So you use a segmentation formula and use SciPy. There are other deep learning clustering algorithms available that you can use. So after segmentation, you check if chunk still has data. So you run it through the entire data set that you have until the chunks doesn't have any more data. You get finished, and then you write that visualization into a new last file, so that you can get you then can get your desired result. So challenges and tips. So you need to keep it easy and simple. So ML calculation takes a lot of processing power. Thus the need to do pre-processing techniques. So it's not you can use like the entire you can use ML to get the entire data set. But given that you want to do it efficiently, so you want to test out with smaller ones, right? So instead of doing that, you do the pre-processing techniques, so you can get your solution faster. So use tools for the right job. Use the right libraries and algorithms. Sometimes there are even more difficult point cloud data formats to handle, which requires a different set of libraries. There are even times when you have to use other languages like R to make some conversion to your point cloud data. So if possible, if you know other languages, you cannot limit yourself to Python only, because there actually, as long as it is a last file, if you process it in R, as long as it's the same, when you process it back to Python, you can still manipulate it the same way. Let's say you just want to add a formula to it or something, or an algorithm. So during segmentation or classification, lots of machine learning and clustering techniques are available. Play and read the parameters until final ideal result is achieved. So there's a popular one that's called PointNet++. So it's being used in MATLAB mainly, but currently there's already a Python version available. So Python's empowerment, so Python's versatility, which are vital for unlocking potential of LiDAR data. So now if you can start as a beginner in Python, you don't have to learn MATLAB. Because when I started this, when I started my thesis, I had to learn MATLAB from the start. So LiDAR significance. So LiDAR technology is transforming industries with highly accurate 3D data. So it's very popular right now. Everything is running, I think, not everything, but it's gaining traction over the time. And we want to get as many skill sets as we want. And point cloud complexity. So there are lots of libraries available. Real-world impact. Real-world case studies showcase Python's practical application in LiDAR, especially in agriculture. Let's say in real estate. Let's say in mining. So there are indeed lots of application to it. Even in cars right now, like. And then, there are even like you can do it with an iPhone, where you turn an object into a 3D version of it, and then upload it to get a virtual version of it. So we gain a deeper understanding of Python's role in processing complex LiDAR data, offering limitless and possibilities in various domains. So I think that's all for my talk. Thank you very much.
Thank you very much. We have a little question and answer session. Can anyone have question? Oh.
Thank you, and thank you for the presentation today. I just wanted to ask, is there anything that exists in the MATLAB ecosystem that still doesn't exist in Python that would make life easier for somebody using LiDAR data?
Yeah, to be honest, lots of pre-built functions exist in MATLAB that in Python you have to do some data manipulations. Like there's some one-liner built-ins like remove noise, like remove like subsample. Where in Python you have to use like NumPy or something. So it's still young, but the community is there's lots of like libraries already appearing. Like recently I found out that PointNet, which is I thought that was only in MATLAB, but suddenly available in Python. So yeah, I think MATLAB currently still has more capability than Python in LiDAR. Thank you very much.
Thank you very much.
Thank you.
Thank you.
Question? Okay. We will have to. We will end Philip-san's talk session here. Thank you very much for your talk, everybody. Please give a big round of applause to the speaker.
Thank you, everyone.
I have announcements, 3 points. 1 point, next talk will begin 35 minutes ago. Next talk begin 3:20. So this is break time here, break time. And second announcement is this break time is poster session time. So if we recommend you go to 20th floor. There are many poster sessions. So go to 20th floor for recommend. And the third announcement is about the party. Party registration is now open, and please go to the registration desk by 5:40 to get a party wristband. Attending the party requires the party wristband, so please go party registration. Thank you. ていけます。なんか読み上げが終わった時間でよしでした。Hello everyone, are we ready to start? If you want to tweet about this talk, please use the hashtag PyCon APAC_1. Now we are going to start John San's presentation. The title is Automating Victory, Beating Browser Games with Accessible Python. Before the presentation, the speaker will read a statement as a microphone test. So please read the statement.
Hello, my name is John Gall, and the title of my talk is Automating Victory, Beating Browser Games with Accessible Python. The presentation will be in English. The materials will also be in English. After the presentation, I'll have things published, as well as directing you to the GitHub where the project can be found. I agree to having my picture taken during my presentation, and I will comply with the PyConjp Code of Conduct.
Thank you. And microphone test is okay. So the presentation time is 30 minutes, including questions and answers. Please welcome John-san with applause.
Hello, everyone. Welcome to Automating Victory. I'm so excited to be here with you all in Japan here together. So without further ado, let's get started. First of all, very sorry. I've had a cold this past week, and I'm fine now, except for my voice. So please be patient with me. But yes, I'm John. I grew up in the US, born in North Dakota, went to school at Georgia Tech in Atlanta. And a year or so ago, I came to Henge to work as a software engineer. You might have checked out our booth, highly recommend it. And last year, I spent some time making a Python script that can automatically beat a favorite in-browser video game of mine. In this talk, I'd like to talk about some of the tips that I found helped me along the way, introduce you to some cool and useful I/O libraries that you might like to use in your own projects, and also tell you about a cool video game. Does anybody here like video games? Okay, bad news, we're not actually playing the video games here. We're making a script to do that. Let's talk about that game, though. Mamano Sweeper was originally released all the way back in 2010 as a Flash game by developer Hojamaka Games. He released an Android port in 2015 and finally updated it to HTML5 in 2016. It's a bit like a Minesweeper and an RPG, where instead of mines, you have to watch out for monsters. But unlike Minesweeper, where clicking the mine is an instant loss, you can click any unrevealed monster at or below your level. And then you'll beat it, get some experience, and reveal the tile. Level up eventually, and you can beat higher level monsters, reveal more of the board, and beat the game. Unfortunately, if you guess wrong and you click on a monster that's too high level, you'll lose hit points and eventually lose the game. Like Minesweeper, the number on an empty tile is a clue as to the neighbors, but unlike Minesweeper, it's the sum of the levels of the surrounding monsters. So here you can see that it's the level 3 because it's next to a level 1 and a level 2 monster. Of course, there's other options. Those other options are where the complexity of the game really comes into play. For example, that same 3 could come from 3 level 1 monsters, a level 1 and a level 2 monster, or a single level 3 monster. And each of those has combinatoric possibilities. So if you add them together, you wind up with 120 compared to vanilla Minesweeper's 56. Feel free to check my math. In one sense, this game is a lot harder than Python. But in another, it's a lot easier. Because if you're level 3 and you see 3 with no empty tiles around it, you can safely click all of them to reduce the overall uncertainty of the game. And that push and pull between whether it's easier or more difficult comes into play in the various difficulty modes. These change the density of monsters, how many it takes to level up, and the spread of levels to give a very dynamic game. Difficulties range from easy all the way up to huge X extreme. The dev's description, yaranai houga ii, or you're better off not playing. And the game is fun. I recommend it. Every time I've gone to a PyCon, I play this game on the flight over because it's very easy, very fun. Bricked my phone, replayed it all except for that last level. We'll talk about that. That last difficulty level is more challenging than anything because you can only click empty tiles, and if you make a single mistake, you lose instantly. I have lost hours to failed runs of this game. Usually I lose maybe after an hour or so, either due to a careless click, bad math executing the strategies, or just bad luck. It's straightforward to play this mode, but executing them perfectly for an hour or so, that's hard. But you know who doesn't have a challenge doing math and input-output for an hour? Well, Python, of course, and I'm in software. This is a solvable problem. So I laid out a very straightforward roadmap. I would make a script that could do what I do, only better. I could look at the board, turn it into a numerical model, use the same strategies that I use, make those moves, and then I repeat until I win or lose. So with the roadmap in mind, I did nothing for about 3 years. And I don't think I'm alone in having projects like this. There's some cool idea, you want to implement, but just all the work to get there kind of turns you off from the whole situation. I'd like to talk about the solutions that worked to get out of this pit for me. First off, this is actually a straightforward roadmap, but it's pretty challenging. Luckily, there's an easy fix where you just do the bare minimum. You take a minimum viable product and you reduce it until it's as minimal as possible. In this case, just answering the question, where is the game board on my screen? Can I find out? And the answer is yes. It's fairly straightforward even. 2 well-known libraries that I highly recommend using. MSS takes very quick screenshots, and then OpenCV to actually locate the board. You might use OpenCV in any number of computer vision topics. It's very powerful, and I'm just using the barest amount here. But it essentially lets me ask, where is this target image in the whole screen? And I got results in an hour of tinkering. They weren't good, they weren't quick, but they were results, and I could iterate on them. Of course, I don't want a picture of the game board. I'd like a numerical model with things like, is there a number in the field? Have I revealed it yet? Something we can use for math later. But even this is kind of a tall order for an MVP. Let's just start by trying to parse the level number. It's static, we need to know it anyway, and it'll help at all phases of the project. Simpler problem makes progress on the whole thing. Of course, we'll want our solution to generalize. Maybe we look into machine learning. Optical character recognition is a well-known field. We aren't doing that. We're just going to match the pixels. It's compare it with the references, since there's only 35 values to choose from there. And that gets us a function. It's not perfect, only works on single digits, but there's room to iterate again. And iterate we do. We generalize to apply to each of the grid locations, check it for double digits, see if it's filled, empty, all by modifying an already working function. Easier to debug when it starts off working than trying to get it up to speed. So we get the model, we can consider strategies, and the simplest one that I found was to click randomly. Don't care about what you're actually going to win, just make sure that you can pick a number. After all, every game starts out with a random click anyway. Speaking of clicking, The library that I use to handle that end of the automation is PyAutoGUI, and it is very well known, it is very powerful. It lets Python scripts send arbitrary keyboard or mouse inputs to your computer. Great stopgap for any weird problem that requires human intervention at some points. Oftentimes it lets you cut out that same human intervention. And the best tutorial I have found by far is Al Swiegert's fantastic book, Automate the Boring Stuff with Python. You can look it up online. He's published this chapter for free. Highly recommend. And with that, we have a fully functional MVP just by looping through the steps that we've already taken. And even though it's a terrible idea to show live demos, I can't resist at least trying to show you what this looks like in practice. Everybody, cross your fingers for me. Hey, there we go. Oh, wow, yeah, it does not do a good job. It's randomly clicking. This is, if it wins, it is by accident. But, you know, that kind of ignores the, oh, safety video. Don't need that, thankfully. But that ignores all the successes along the way. This is either a terrible way to play a video game, or it's a bunch of really cool automation techniques that just haven't quite finished there yet. I find the second mindset is a lot better for personal projects and maintaining them until they grow into something you like. Of course, we're not done. I do want to revisit that simple strategy I hinted at earlier. And that strategy is that if you see a number at or below your level, the adjacent squares can't contain dangerous monsters. So those red boxed can be at most 1. It's very quick to do, something that you would do while playing. And pseudocode might look like this. Check out every row, column. If that number is below or equal to your level, go through every neighbor, add it to some safe-to-click set. And it's fine code, like this would work 100%. But Python is notorious for not liking nested for loops. And this didn't really leave me satisfied when I came to this solution on my way. But it'll work, so why spend time optimizing something that'll function? I mean, I care about it, in short. It was my original question when I set out on this whole journey that I wanted to make something that could implement my strategies and do it well. And that brings me to the second takeaway from this, that you can't waste time by learning. And optimizing something is a great way to learn. NumPy, for me, is one of those fantastic tools that shows up everywhere, but is a little intimidating to crack into. If you haven't used it, it does array and matrix operations very fast because it's all vectorized under the hood. Of course, it's easier to learn it one function at a time to solve a specific problem. For example, can we just go through every grid and column location to find if it's less than or equal to the level? And the answer is yeah, because NumPy stores things as a vector, it can determine whether it's above or below the level at all times, roughly in parallel. And then you can simplify the for loop. But we aren't satisfied with that because there's still a nested for loop. And then the question becomes, can we do something for depending on neighbors, for every place in a grid? And if you're like me and have a little bit of background in computer vision, that sounds like numerical convolution. And this is not a talk on numerical convolution. There's so much cool stuff to get into. Just gonna go over the barest overview. You slide a moving window called a kernel over a grid, multiply the kernel by the underlying grid, and then add the results together. Scikit-learn has a great function for this that plays very well with NumPy. And of course, because this shows up in image processing and machine learning, a lot of really smart nerds have optimized this stuff, so it's blazing fast to use. So the question is, can we use this for the process we want? And spoiler alert, we can. What we do is we start off by doing that vectorized check as to whether a number is above or equal our level, here symbolized by highlighting those squares. So that's a Boolean array. And if we slide a kernel that adds the neighbors over this array and add it, we'll only get a number greater than 0 if it's next to a grid with a low number, those blue squares on the right. So if we put that all together, we start with that vectorized check, go for the convolution, check what numbers are above 0, and then we can simply use a NumPy Boolean AND across the two arrays of what's unrevealed and what has a low neighbor, and we'll get that set that's safe to click without any loops. It's a 10 times speed up, and of course, it's a strategy that's actually useful. So here again, I can't resist. I have to show that it's a useful strategy. There we go. It's a useful strategy and runs quite quickly. Uh-oh. Oh, did we have one good demo and it wasn't even the good one? I'm gonna cry. Oh, no. So yeah, all of a sudden, it's actually capable of finding things and it solves, oh, it ran straight past the victory screen. Let's do it again. It takes only about 5 seconds compared to the few minutes that a seasoned player could spend on it. Yeah, 4 seconds, there we go. Good job, script. Of course, it's not perfect at this point by a long shot. Oh, it's terrible. There's a brown grid there that's difficult to see. It's the normal mode, and it's the step up. Here, if you run the script again, you'll find that it can sometimes get fairly far, but there's just not enough info. As I mentioned earlier, the denser the monsters are, the more trouble it has, and the more sophisticated strategies it needs. Yeah, see, can't actually get there. We're gonna need to be a little bit more sophisticated if we want to actually solve the game. Skip the safety video, thank goodness. Of course, the question is, was this worth it? It was a lot of optimization for something that would have worked out of the box. And in fact, if you crunch the numbers, it's blocked by I/O pretty heavily. A lot of the script is just spent clicking and taking the screenshot. Removing all of the strategy would only save 3%. So was it worth it? Yes, of course it was. I'm telling you that it's worth it in this whole talk. It's worth it because learning NumPy and scikit is really important for later phases of the project. Later, the strategies involve very sophisticated use of NumPy and some convolution things that are either really smart or really dumb. Feel free to check out my GitHub to see for yourself what you think. And of course, it's also a great way to learn in general. Experts on education call it just-in-time learning, and it changes convolution from something you learn in a class of blur or sharpen images to, oh, well, here's how it works, and here's how you can use it to help yourself. But we aren't learning to learn, we're learning to win. The third thing that kept me going through all of the bug fixing, all of the confusion, was glory. If you go to speedrun.com, you can find fast times to beat most video games, and Mama No Sweeper is not an exception. My goal from the beginning was to get the top time using my script on all versions. So you can see that the human times are pretty quick. We've already beaten the easy mode, but we can't come close on normal yet. And the huge X Extreme, about 13 minutes. So let's give it a try, see if we can beat the huge X Extreme version. There's a lot of things to click, which is why it takes so long. And this is the final version with more sophisticated strategizing. It'll struggle too for a little bit. Again, it's limited by the amount of information available and visible. But I find that once it can get a foothold in one of the corners, it has a lot easier of a time. And what I'm really proud of here is that it goes through with strategies that I could describe to you in words. There's no black box, no AI under the hood, shaping it to go one way or another. It's doing strategies that made sense to me and that I converted to code. It's also doing them pretty darn fast. We just finished in 30 seconds. Thank you all so much. I am grateful that the live demos worked with fewer headaches this time. Grateful that I don't need the safety video here either. So as you can see, I ran them a bunch of times. I got my best times, everything down under 30 seconds. I felt like I really hit some major milestones, but of course, I know it's not perfect. The blind mode I mentioned has so little information, the script can only succeed 1 out of 20 or even 1 out of 100 for the difficult mode. And I want to improve it still. 2 strategies I see for this are either leveraging neural networks or some sort of statistics-based solver. The advantage of the neural network is that the training data is a piece of cake to use. It's already a grid of numbers. Neural networks love grids of numbers. And it might be able to capture that intuition that a human player develops after playing enough time. Of course, why I haven't done this is I'm not very skilled at AI stuff. I don't know how to make those inroads that let me succeed in the project as a whole. Meanwhile, the statistical solvers are basically guaranteed to work. When you see a number, there are various configurations that could result in that number, and some are more likely than others. If we compute all of the permutations, find which places are the least likely to have a dangerous monster, we can click there. It's hard, but it's guaranteed to work, and there's existing problems that are very similar, like the partitioning problem or constraint satisfaction, which you might know because those are actually NP hard problems. And it's even worse than that. Finite Minesweeper is NP complete. If it's an infinite board, it is Turing complete. Meaning, yes, you could play Minesweeper by seeing if you could play Minesweeper on an infinite grid, which is kind of horrifying. Of course, this scares me away from statistical solvers, but those only indicate classes of difficulty. In real life, hacking together a neural network or some statistical solver only has to be random chance to make my script better. And it always tempts me to come back. We'll see for the future, but I don't feel bad about stalling out on the project when it's coming up against NP hard problems. And I hope that you had something to take away from this. Of all things, this project was great for teaching me goal management. And every step, I could reframe the problem to be just a bit more difficult than I was capable of. And I could do that straight through to the end. Of course, the opportunities to learn were really excellent, and completing the goal felt undeniably great. And in your own projects, mind the loop of MSS for screenshots, use OpenCV to parse the image, and PyAutoGUI to click, and you can do most things that you would at a computer. And this feels like a very logical place to end the presentation, but I can't shake a very unsettled feeling about this whole thing. Originally, I completed the script, did the last push to GitHub, November 16th, 2022, and I thought it was pretty cute. And then 2 weeks later to the day, ChatGPT had a general release and changed what we consider computers can do easily. Broadly speaking, the script looks at the computer, it thinks for a bit, and then it clicks based on where it thinks. And suddenly, that thinking step got a lot more interesting. Obviously, this can do anything that you can do at a computer. I'm not naive. This has some antisocial potential. Take, for example, Twitter's controversial decision to shut down its free API tier. Ostensibly, this will shut down a lot of evil botnets and good research projects, art projects, etc. But they can't eliminate the ability for a human to interact with the main page of Twitter to post a tweet. And as you all can imagine, it's easy to have that tweet generated to whatever the programmer wants. And you might be thinking, well, what about CAPTCHAs? And what about CAPTCHAs? This unnamed service that solves a CAPTCHA with a real human at the other end through an API endpoint wasn't hard to find. And that's on top of the really incredible research papers coming out where people are trying to do deep learning to beat CAPTCHA solving problems. So I think that, unless you're doing it for something like account setup, then it makes sense, but ultimately people will get scared away if they have to complete a CAPTCHA just to send a tweet. One solution that absolutely stopped me in my tracks was a complete redesign of the game. 2 weeks before I was due to give this talk at PyCon Taiwan, I found that the developer went back to this decade-old game and fixed it. It's a much better experience. Please check out the website. Of course, this ruined the image landmarks. All the grid widths were suddenly dynamic, and worst of all, it no longer accepted clicks from PyAutoGUI. I was panicking, trying my best to hack the script back together to make it work. And I found that the dev, after pressure on Twitter, not from me, put the old versions up on this website again, which reminds us that even if you do something very drastic to get in the way of scripting, unwelcome scripting from outside parties, it's a setback, and it'll get pushback from the very real people who use whatever product you're trying to harden. Ultimately, it's a challenging topic. How do you stop, automated harassment, misinformation, bullying? As developers, I still think it's worth automating what we can. We have a position to get away some of the drudgery of life, some unpleasant tasks, and I think we should try to do so. At the same time, we should do sensible checks where we should for whether someone is a human. I don't think it's unreasonable to put a CAPTCHA to make a new account on a website. And of course, we should do what we can to limit what a bad actor can do anyway. If there's a big red button and pressing it blows up the world, I don't care if it's a robot pressing it or a person pressing it. I don't want that to happen. I think there's more to be done to solve this problem as people. I think we should be kind to each other. I think we should foster communities with each other and make it so that when someone is hateful, spreads misinformation, bullies online, it stands out and we can shut it out, whether it is a person or a computer. Thank you so much for your time. I do have some time for questions. The common ones are, is this open source? Yes, please check out my GitHub page. It's jgall3/TASWEEPER. If you'd like to get in contact with me, my email, john.gall@henge.com, my Twitter, or X, I guess, @JohnGhoul. We should be coworkers. We got a recruiting site. Check out the booth. And if you would rather read this presentation, there's a series of blog posts I wrote on Henge's blog. You can feed it through a machine translation if you like. Should work a lot better. So please, if there's any other questions, I'd be happy to answer them now.
Thank you for your presentation. If anyone has questions, please raise your hand.
All right, thanks for the great talk, John. Just one question. Has you ever found out what happened, why the Pi auto GUI the click doesn't work anymore?
A fantastic question. So I was really working. I managed to fix the landmarks issue, the grid widths issue, and I was just down to the clicking, exactly. And I think it's some underlying event listener that changed to where it required more of a delay between mouse down and mouse up. So by tuning that, I was able to get it to register clicks, but it wasn't nearly as fast. I think it might also have something to do with how it changed the rendering timing. For some reason, like whether it was a different size had some effect. It's actually a great question because it points out that to the computer, like a click is one thing. But to a human, we don't care about what event happens. We press the button, it does the thing. Exploiting that is honestly one of the best ways to prevent automation. But yes, thank you so much.
Okay, thank you. I have a question about how you define the pixel, which pixel that you have to click, and then how you get that pixel, because I have this kind of job that requires me to clicking a lot of stuff, click this and then write this. I know about the Python GUI. I have tried to do that, but there's this event that it's kind of dynamic, and I need to find some text and go to the text, and then I use that. So I'm still trying to figure out how can I find the pixel location of the text so I can write something and I can click something based on that.
Fantastic question. Side note, if anyone automates their job without telling their boss, please tell me on Twitter. I am going to be so thrilled for you. But this is where OpenCV actually comes in really handy. So I mentioned this match template function where you provided a reference image and then you check in a larger image. It doesn't give you a Boolean. It gives you a field of probabilities. So if it's pixel art, it's very easy to get almost 100%. But depending on the situation, you might be able to give a very close approximation that's 70% correct and still looks where you're looking for. Additionally, if there was a way to dynamically render what pixels you need to make that reference image ahead of time, I think that would be a really interesting way to tackle this problem. Although, yeah, it does point out the fact that this game is pixel art makes it a lot easier. Thank you.
Can I have a follow-up question?
Oh, please.
So, you sometimes that we need to find text, not so there are a lot of text that I need to find, and then if we look at this reference it landmark, so it's not a text that we already get the image. So, do you think that OpenCV can handle that? OpenCV alone can handle that? We need to search this text. We need to search this text.
OpenCV alone, I don't think could handle that. If it's searching within a web page, I would recommend something like Beautiful Soup that takes the whole HTML and just gives it to you as a searchable string. Oh, there we go. Gives it to you as a searchable string. I think that might get more to what you're looking for here. Alternatively, I think if you could, in a controlled environment, feed the text in and format it and then take a screenshot of that, then you would have the reference image that OpenCV could do. But I don't know if it can just find this string in a picture image. Am I understanding correctly?
Yeah. Okay. I understand. Maybe because it's not yet, maybe that's gonna be our job that I think I'm gonna try to create something to solve the problems. Thank you.
Sounds good, thank you. And let me know about your progress. I'd love to hear about it.
Sure. I'm gonna share it to you.
Other question?
Sorry, just one more question. Anywhere you want to take this further?
Oh my God, I alternate between wanting to do more on this and never touch it again. But every time I come to the slide about solving it with statistics or neural network, I'm always like, well, it's not that much of a trap to try this. Surely it's like a one-day thing to at least get a testable solution up and running. And I think once I had that testable thing, a way of testing whether a strategy actually improved objectively versus subjectively, I think that would be a great next step that I could reasonably do. Maybe after this PyCon season. Thank you.
Have you thought of reaching out to the creator of the game to collaborate on using what you've made to do some sort of testing so they can automate against what you're trying to achieve, which would be cool, and to not let other people have so much fun by exploiting it, if that makes sense?
I mean, part of what I find exciting about this project is that it's something that the original author of any system can't get in the way of as effectively, because it is just interacting with the game the way the game wants to be interacted with. It gets clicks, it doesn't care about how fast they are. But honestly, the redesign has slowed me down so much and slowed down the clicking especially. I think the dev has honestly done a good job unintentionally of blocking this. Although I did reach out and say I really enjoyed his game. Thank you.
Awesome, thank you.
Sorry, time limitation. So last question, please.
Thank you for the talk, John. And I think it's not a question, just an idea. Yesterday morning, there's a keynote talk talking about Python programming education in University of Kyoto. So I just thought about maybe your kind of this project can be put into some sort of steps and put into his book as a kind of another kind of tutorial or some sort of coding idea. That would be really interesting.
That would be fantastic. Just delightful if this, of all things, wound up in a college textbook. Thank you so much, though.
Thank you for many questions. And I accessed the TA sweeper repository, and I start very nice repository, and I found slide. So, ぜひ let's access this repository. So the time is up. We will have to end here. Thank you very much for your talk. Everybody, please give a big round of applause to the speaker. If you have any questions and would like to talk to the speaker directly, please go to the hallway or open space. Speakers will be around, so we ask for your cooperation in not gathering around the stage. And announcement, next content is lightning talks and closing. And lightning talks and closing held this room. And many people come to this room, so please, so everyone can sit. So please, 譲り合っておかけくださいみたいな。Please sit together. Thank you for your cooperation. And
so this room will be filled with many people, and so some people need to go to other rooms so that they can see the YouTube live of this room. So yeah, please do not make empty seat. この後この部屋 LT で混み合いますので、皆様譲り合って詰めて座っていただきますようお願いいたします。
LT の登壇の方、今のうちにプロジェクターにつながるかどうかを試してみてください。結構AV 系のトラブル発生しておりますので、LT される方、今のうちに映るかどうかだけでも確認しておいていただければと思います。So as well announced and on the screen, we will have an official party from 6 p.m. at 20th floor. But if you haven't get this band, please go to the reception with your QR code to get this band. So registration for official party or exchange to this band or for official party will be closed at 5:40 at the same time as closing will end. So please go to the reception now. 今後で言うの忘れてました。オフィシャルパーティー6時から、20階であるんですが、まだ来てないです。来てない。はい。で、5時40分にレセプションでの、ギグバンドへの QR コードからの交換を、終了いたします。その時間というのはクロージングが終わる時間と同じですので、ぜひ今のうちにレセプションに行って交換していただくようにお願いいたします。まだ。まだ。あ、来た。来た。 来ました。まだ真ん中の方ちょっと空き席ありますので、皆様お詰め合わせいただいて皆様が座れるようにご協力お願いいたします。
Is there any LT speakers who will talk but who haven't tested connectivity yet?
There is some vacant seat in the middle of rows, so please come into the front to get your seat. はい、では、予定の16時40分になりましたので、本日の最後のセッション LT 大会とクロージングを始めたいと思います。So now we are at 4:40 as a scheduled time. So we will start LT sessions and closing talk from now. では、1人目横田様、接続お願いいたします。So we will have
トラック3が微妙に。
はい。了解です。So we will have 3 lightning talks from our sponsors and one another from network operation team. So in total, we will have 4 lightning talks from now. ということで、今から、3本、スポンサー LT をやって、もう1本、ネットワーク運営チームから今日の振り返りのライトニングトークを1本やっていただきます。で、その後クロージングとなります。ただいまちょっと他の会場の準備を待っておりますので、もう少々お待ちください。まだ前の方、特にこちら側の前の方とか、まだ席が真ん中で空いておりますので、ぜひ座席に座ってみていただければと思います。であと先ほどもアナウンスいたしましたが、オフィシャルパーティー、6時から20回で行いますが、まだギグバンドに交換されていない方、5時40分に交換をレセプションでの交換を締め切りますので、それまでにぜひ交換されるようにお願いいたします。では、準備が整いましたので LT 大会始めさせていただきます。1つ目の LT は架橋さんから横田直彦さんで PyCon でスナップショットテストということで、LT 5分間よろしくお願いいたします。
はい、よろしくお願いします。私からは Python でスナップショットテストというタイトルで発表させていただきます。お前誰よということなんですけれども、横田と申します。エンジニア歴9年ぐらいで株式会社架け橋でエンジニアしております。で株式会社架け橋は薬局業界でシステム開発しているんですけれども、先ほどのブースでもラムネを処方させていただいてたかなと思うんですが、そういう会社で働いていて、でその会社では結構業界変化があるので、そこでスクラップ&ビルドしやすい Python を採用しているというものになります。で私自身 Python 大好きでして、普段使い仕事でもプライベートでも Python を使っております。今日はどうぞよろしくお願いします。ございます。早速ですが皆様、テストのメンテナンス大変じゃないでしょうか。実際にエンジニアとして働くんだったらなんかテストのメンテナンスに時間使うんじゃなくて、機能の開発に使いたいですよねと。これらの悩みはスナップショットテストで解決できます。スナップショットテストとはどういうものかということなんですけども、前回成功した時の結果との一致を確認するテストで、Python にもいくつかライブラリがあるんですけれども、それを使えば簡単にテスト作成したりとか更新をすることができます。具体的なところなんですけれども、例えば JSON 文字列を返すような SUM ファンクションというものがあったときに、今までのテストだったら JSON の中身に対して、アサート文を何個も書いていくみたいな、そういう書き方すると思うんですけれども、スナップショットテストを使えば、ファイルの中に JSON 丸ごと格納しておいて、それとの一致でアサート文1個書けばテストを作れるというものになってます。あとはコマンド使えば更新もできちゃいますと。でそれはいつ使うべきなのかというところなんですけれども、私としては、仕様が頻繁に変わるような関数のリグレッションテストだったりとか、テストがない関数をリファクタリングしたいなっていう時に、とりあえずスナップショットで守っとけみたいなやり方だったり、あとは関数のレスポンスがかなり大きい時に使うのがいいなと思っていて、弊社の場合ですと API のレスポンスのテストだったりとか、ETL 処理の関数のレスポンスのテストとかに使っていて、体感だとだいたいメンテナンスコストが3分の1ぐらいになっているかなというふうに感じます。ただ使う時に注意点があって、デメリットとしては、誤ったテストを作っちゃいがちかなと思ってて、スナップショットテストの中身を細かく確認するのって結構難しいので、そこはちょっと気をつけないといけないかなっていうのと、例えば日付が関数のレスポンスに入る時とかは、毎回値が変わっちゃうので、スナップショットテスト毎回こけちゃうみたいなことがあるので、そこは注意が必要になります。Python のライブラリだといくつか探してみたんですけれども、あんまりメジャーどころがないのかなという印象ではありました。スターヒストリーとか見てても、多くて500ぐらいというところなんですけれども、でも実際に使ってみると割と便利なライブラリがいくつかあったので、今回2つ紹介させていただきます。1つ目が PyTest スナップショットというライブラリで、こちらはスナップショットをファイルに保存します。で使い方なんですけれども、PyTest のフィクスチャーが提供されるので、スナップショットっていうフィクスチャーに対してアサートマッチっていうメソッドを呼び出せば、ファイルとの一致を確認してくれたりとか、あとはテストの、ファイルの中身スナップショットの更新も、オプションコマンド1個で更新することができます。で2つ目がインラインスナップショットっていうやつで、これはスナップショットをテストコード上に保存して、それとの比較でテストを行います。でこれの使い方なんですけれども、スナップショット関数をインポートして、でそれを期待値エクスペクトの値のところにセットします。で、クリエイトのオプションで実行すると自動的にスナップショットをテストコード上に書き込んでくれますと。でこれはディクショナリーとかもスナップショットにできるのでめっちゃ便利なのと、あとはパラメトライズテストでも使えるのでかなりおすすめです。今回紹介した2つの使い分けに関してなんですけれども、ファイルに保存する場合だとテストコードがかなりシンプルに書けるのでいいなというのと、あとはスナップショットがファイルに落ちるので、Git とかでその前回との差分確認できたりするので、結構便利なんですけれども、エディターとかでそのファイル1個1個開いていると、そのエディターがめっちゃ煩わしくなっちゃうみたいな問題があります。逆に、テストコード上にインラインで書く方法だと余計なファイルが増えないのがメリットで、逆に、大きいスナップショットが、テストコード上に書かれちゃうと、テストコードが難読化してしまうので、そこはデメリットとしてあるかなと思うので、使い分けとしては関数の結果が大きい場合はファイルに保存して、小さい場合はインラインに保存するのがいいんじゃないかなと思っております。はい、以 以上スナップショットテストを使うと簡単にテストの作成とか更新ができるので、はい、やって頑張ってください。はい、最後ちょっと宣伝で、はい、弊社新規事業とかPython のデータエンジニアとか募集しておりますので、興味のある方はぜひご応募ください。ご清聴ありがとうございました。
はい、横田さんありがとうございました。次ファインディさんご準備お願いいたします。なかなかテストコードって書いたりメンテナンスするのが難しいなと感じている常日頃なので、いろいろなんか勉強したいなと。私なんか本業は W3C というところで使用書しか書いてないんですけど、ブラウザの実装が正しいかテストするHTML とかを作ってるんですが、HTML がバグっていて本当に正しいかどうか分かんないみたいなことがあったりして、はい、というところで2社目、ファインディさんから笹野翔太さんで MLOps 導入と GPT 活用ができる ML 組織になってきた話ということで5分間ライトニングトークいただきます。笹野さんよろしくお願いいたします。
はい、よろしくお願いします。MLOps 導入と GPT 活用ができる ML 組織になってきた話ということで、ファインディ株式会社 CTO 直下のデータソリューションチームというところに所属しております。機械学習エンジニアをしております笹野と申します。よろしくお願いします。で、私は現在ですね、既存アルゴリズムのアップデートでしたり、新規施策の POC といったような主なことを主な業務としております。最近の悩みはですね、すごく個人的なんですけれども、寝るのがすごく下手くそで、どういうことかっていうと、朝起きると、首と肩が凝った状態からスタートするということになってまして、今日は元気に起きられたので、寝るのを成功しております。よろしくお願いします。で本題に入る前にですね、簡単に手掛けている事業ですとか所属チームの紹介をさせてください。ファインディでは挑戦するエンジニアのプラットフォームを作るというビジョンのもと、転職サービスのファインディ、フリーランスのマッチングサービスのファインディフリーランス、組織パフォーマンスを可視化するファインディチームス、転職サービスのグローバル展開版であるファインディグローバルといったサービスを開発しております。これらの事業をですね、横断的に行ったり来たりするのが我々データソリューションチームでして、現在この5名で編成されております。我々の仕事はデータ分析、機械学習、その他アルゴリズムによるサービスの価値によりサービスの価値を向上させることになっています。これまで GitHub を解析してスキルを定量化するスキル偏差値ですとか、ユーザーの年収予測、各種レコメンデーションなどですね、さまざまな既存のアルゴリズムの改修や新規開発に取り組んでいたりします。でここからが本題となるんですけれども、今日は直近取り組んだ MLOps の導入と GPT 活用の2つについてお話をいたします。まず MLOps についてからです。ファインディではですね、社内で通称おすすめ順というユーザーと求人のマッチ度合いを計算して、求人に対してユーザーのレコメンドをするという機械学習モデルを運用しております。マッチスコアは求人情報とユーザー情報から計算をして、その結果をもとに各求人に対して親和性が高いであるユーザーさんをレコメンドしております。ところがモデルの学習が不定期かつ Jupyter ノートブック上でつどつど再学習を走らせてファイルを手動で S3 にアップロードするというですね、非常にイケてない運用状況でした。というところで、これをイケてるものにしたいというので MLOps 導入に乗り出しまして、Vertex AI のモデルの自動学習パイプラインを構築するというような実装をすることで解決しようとしました。でついでにですね、GitHub Actions で CI を構築して、この下の図のようなフローをですね定期実行化することで、それを実現しようとしました。でまたですね、学習ログの記録兼モデルのバージョニング管理ツールとして今回は ML フローを選定しているんですけれども、そこもこだわりポイントの一つだったりします。でこのようにですね、運用コストを下げながら常に一定の精度を保ったまま運用できる状態を実現することができました。続いて GPT 活用についてです。で今年の3月にですね、チャット GPT キャリアまとめという機能をリリースさせていただきました。これはチャット GPT にご自身の経歴をまとめてもらって、それに名前を付けてもらうといったような機能になっています。具体例で画像を載せてあるんですけれども、資料を後ほど公開いたしますので、よければご覧になってみてください。でそれと今回は時間の関係で詳細は割愛させていただくんですけれども、リリース後にですね LT に登壇するような機会がいただきました。そこでの資料をですね、こちら掲載していますので、よければご覧になってみてください。また詳細はですね、今現在はお話しすることできないんですけれども、このほかに社内でも GPT 活用さまざま進めております。 でその他にもですね、チームとして今日紹介しきれないような取り組みの一部として DBT を導入してデータのべき統制を担保して各事業部で追う数値の共通化を図ったりですとか、社内のインフラチームと協力しながらデータ基盤の構築だとか運用に向けて整備を進めているといったようなことも行っております。このようにですね、少しずつやりたいことができるようなチームになってはきたんですが、なってきました。さらにアルゴリズムのであったりですとかデータ活用に力を入れるという会社の方針もありまして、チーム全体にですね追い風が吹いている状況もありまして、チームの特徴としてやったことが成果になりやすいといったような状況におかげさまでなってきております。なんですけれどもまだまだ伸びしろという部分もありまして、既存アルゴリズムのさらなるアップデートですとか、施策の効果検証の土台を醸成するですとか、進捗中のデータ基盤の構築を進めていくですとか、将来のための新規開発ですね R&D 的に進めたいですとか、とにかく伸びしろはいっぱいあるんですけれども、ご覧の通り人が足りないような状況になっております。今日の発表をもし聞いていただいてですね、データソリューションチームに興味を持っていただいた方いらっしゃいましたら、一緒に開発してくださる方募集しておりますので、ぜひお気軽にお声掛けいただければなと思います。最後にこちら募集要項になっておりますので、ぜひいろいろお話ししましょう。よろしくお願いします。
はい、笹野さんどうもありがとうございました。資料は後で公開ということなのでぜひご覧ください。So third speaker is from Henge. Jasmine さん please prepare your slide. 業務連絡です。NOC チームの LT スピーカー決まりましたでしょうか。NOC チームの LT スピーカー2人 OK はい。会場に来てたら大丈夫です。この次なので、はい、よろしくお願いいたします。すみません、なんか全然最初に説明してなかったんですが、LT、昨日はYouTube で音流しました。今日はちゃんと物理的なドラを持ってきたので、物理的なドラでやっております。はい、英語、日本語。英語。英語、はい。So, third writing talk for today is Jasmine Yap-san from Henge, titled as Creating Writing Talk in the Terminal. So please start your talk for 5 minutes.
Okay. Good evening, everybody. I'd like to talk to you today about creating a lightning talk in the terminal, or at least I tried. So yeah, my name is Jasmine, and I'm a backend developer at Henge, which is a cloud security company based in Tokyo. I use Python mainly in my work for web development, and I attended my first PyCon last month in Taiwan. And thanks to Henge, who's sponsoring this year's PyCon APAC, and who will also be providing the venue for the sprint event tomorrow, I'm here to give a lightning talk representing my company. Yeah, so back to the topic. You've probably already noticed that these slides are actually running in my terminal. It is actually a terminal app that is built using a TUI library called Textual. And so in Textual, we can create screens, which are just objects that occupy the dimensions of the terminal. And we can switch between screens. So it got me thinking, presentation slides are just screen objects, so why not build this whole lightning talk as a textual application? So for a basic textual application, all we need to do is just importing and extending the app class by specifying the CSS, the path of the CSS file that we'll be using, the collection of screens, and the behavior of the application on startup. That's basically it. Yeah. And here, I'm going to talk about 3 things I like about Textual while building my my lightning talk terminal application. First, it is async agnostic. So, meaning that it works on both async and sync contexts, and it is an asynchronous framework, but it doesn't require the developer to use async and await keywords. And every UI component, or what they call widget, in Textual runs an async IO task, and they can independently update and communicate with each other through message passing, which is pretty cool. And secondly, there is many built-in widgets that you can use for your terminal applications provided by the library that are interactive and dynamic. For example, like buttons, checkbox, markdown, text area, progress bar, etc. And they support CSS for styling, and specifically, they use a more simplified CSS dialect compared to web-based CSS, which is good news for me as a backend developer who almost never use CSS ever. And it's also very easy to add and create new widgets. So for example here, this is a markdown component, so what I did is just do yield markdown, and I have checkbox over here, and I can just interact with it. And there's a text area here, which shows the code I use for this app. And all the CSS I did is just the color and the padding, and the interactivity here they all come with the app itself. PyCon, hope we can see that. Yeah, that being said, Textual does not officially support images yet, but there are third-party libraries available to write pixel images to the terminal, but it's quite limited. And textual apps do not look that good on the default Mac OS terminal, which is what I'm using right now. So for borders, as you can see here, there are like misaligned lines. Yeah, anyway. The third thing that I like about Textual is that it supports, it has the CSS live editing feature. So with the dev flag, we can edit CSS and see the changes without restarting our terminal app. So on the other hand, what about like changes to Python code? So I use the PyTest watch library and run with the runner flag to kill my application and rerun the textual command again. It's not really live editing, but it does the job, and it was really helpful for me when I'm debugging this Lightning Talk app. Yeah. So thoughts, is it worth it? Debatable. It took a longer time than I expected, just for this Lightning Talk. Was it fun? Yeah, it was fun. Like I got to learn a lot of like how to build a terminal app. I've never built a terminal app before. I didn't even know about terminal app before this, so. Will I do it again? Yes, but on something more practical. This is, just use Google Slides. Hi, and yeah, so thank you for listening. And yeah, we're hiring. I'm from Hangei, and I'll just put this on for like 10 more seconds. I have 10 seconds. Yeah. Thank you. Thank you.
Thank you, Jasmine さん for your talk. いやこれは鳴らせと言われたのかなと思います。次ノックのスライLT です。今日はさまざまなトラブルを迎えてしまいまして、一時期インターネットを使えない状態に陥らせてしまいまして、誠に申し訳ございませんでした。
はい、すいませんでした。参加者の皆様、スポンサーの皆様にもちょっと、ご不安やご不便を、与えてしまったことはちょっとノック代表して私は謝らせていただきます。すいませんでした。
はい、というところで、スライドが出たので、はい、タイトルが変わった？はい、PyConJP ノックチームから、お二人来ていただきまして、今回期 Wi-Fi システムのポイントということで、PyCon APAC2023 の Wi-Fi を支える技術というライトニングトークをいただきます。ノックチームの皆様よろしくお願いいたします。
はい、よろしくお願いいたします。はい、今回2人体制で発表するんですけど、まず最初に私、ノックの、テクニカル的な面で支えていた熊田と申します。よろしくお願いいたします。で、今回私どもは、上流に、10ギガの回線を引き入れて、できるだけ快適な、来場者ネットワークを組もうというところを、頑張ってみました。ということで快適なネットワークのため上流回線フレス光クロスを採用というところなんですが、ご使用感いかがでしたでしょうか。ちょっと、一時期使えないタイミングで出てしまったと思うんですけれども、使えているタイミングの時、快適に使えていたというところであれば、私たち満足できております。はい、ありがとうございます。はい。あと次、バックボーンですね、トピックスとして IAC、インフラ、アザーコードというところで、ネットワークサービスの IAC が、DHCP だったり DNS だったり、ネットワーク提供するにはいろいろなものを、裏側で立ち上げる必要があるんですけども、これ今まで、私ども手で温かみのある作業を行っておりましたが、はい、今回、Docker でまとめてどんな環境でもエンターボタン一つエイヤーという Docker コンポーズアップデートってやれば上がるようなところまで コード化することが成功しましたというところで、サーバー立ち上げの属人化や作業コストが低減できたかなと思っております。というところで私熊田からの発表は以上です。はい、バトンタッチします。
はい、ノックの井口です。僕はサーバー系と監視、可視化系を主にしたんですけど、今回は監視についてお話していこうと思います。今回 IAC 化がトピックということで、基盤にはDocker を用いました。で、今回構築したすべてのサービスっていうのがコンテナで構築されています。そして監視基盤自体は Zabbix とプロメテウス、あとはプロムテールなどを用いて、主要なのだと、死活監視だったり AP に対する、接続数だったり、ログ監視とかっていうのを取得していました。ちなみに、接続数のピークっていうのは617になりました。はい、それをデータソースとして可視化にはグラファナーを用いました。そしてちょっとだけニューレリックさんも、入っていたりします。ログの可視化には、Python のライブラリであるプラグインなどを使っていたりします。ノックのブースのスライドはこんな感じなんですけど、実際にダッシュボードを見てくれたよっていう人いますか？ありがとうございます。ありがとうございます。実際に見てもらった方には伝わったと思うんですけど、やっぱりグラファナーすごく綺麗にビジュアライゼーションができて、たくさんの方に、写真を撮っていただくことができました。グラファナー綺麗だったよっていう方、ありがとうございます。ありがとうございます。はい、良かったと思います。そして今回この可視化をウェブでも配信するっていう試みをしたんですけど、なんと配信の前日にレンダーが動かないっていうことが、急遽判明して、もうノックチームで急遽レンダーを実装するっていうことをしました。で、それはもちろん言語は Python です。そして、裏でネットワークを張っている中、なんとか、必死に構築して、配信に至ることができました。自分はまだ学生なんですけど、なければ自分で作るっていう、ノックのエンジニア魂みたいなのを見せられてよかったなと思います。はい、で来年は、もう障害ゼロのシステムを目指していきたいなと思います。ご清聴ありがとうございました。
はい、PyConJP 2023ノックの皆様どうもありがとうございました。以上で今日の4本のライトニングトーク終わりになります。ここからクロージングになりますので、皆様、準備が終わるまで少々お待ちください。あと再びアナウンスですが、5時40分になんだっけ、オフィシャルパーティーのギグバウンドでの交換終わりますので、それまでにぜひレセプションで QR コードを見せていただいて、交換していただくようお願いいたします。オフィシャルパーティー、20階で、クロージングが終わった後、20階の会場の前で、受付を始めますので、そちらもご利用ください。So, we will resume reception of official party starting from right after this closing at the 20th floor, not a reception at 4th floor.
Hi, はい、皆さんお疲れ様でした。Day 2クロージング始めます。
Okay, everyone, good evening. We will start now the closing of day 2.
まず最初に落とし物です。
Lost and found. We'll start with lost and found, and it's our good old friend.
メモリーがまだ見つかってないです。お心当たりある方、ぜひこちらまで。
Please either claim this or we will use it next year to make the Wi-Fi better somehow. I heard that this is like an antique. It's from the Pentium era, so. Okay.
続けて、トートバッグですね。トートバッグと中に入っているものがありました。多分これもノベルティだと思うんですけども、こちら忘れた方いましたら、こちらまでお願いします。
Yeah, this is again the bag from this morning. If you lost it yesterday during the closing, please claim your bag.
続きまして。
5,000 yen.
5,000円。これはプレゼントではないです。
If you wish to claim it, please tell us the serial number on it.
はい、現金を落とした方いましたら、またこちらまで聞いてください。
Yeah, no, seriously, if you did lose it, please tell us where you lost it and when.
続きまして、iPhone。
An iPhone with Touch ID, so
SE かな、なんか
maybe SE?
8のような形、8SE の形ですね。
With this kind of thing at the back. This was found in the west side's 4th-floor men's restroom.
西側の男子トイレにあったということです。
So, yeah, check if you have your phone on you, otherwise come talk to us, please.
続き。
Next is a bag full of other bags and various other stuff, and also a really cute T-shirt.
お腹空いてます猫ちゃんの餌くださいという T シャツ T シャツなんです。T シャツ変化
何
なんかじゃあ後ほど詳細教えてください。
So yeah, if there's lots of other stuff in here. So if you lost your really cute cat T-shirt, please do let us know.
はい、続きまして次はい、振り返りとなります。
Okay, let's have a quick look back at over the last few days.
はい、今回アジア地域でやることということで PyCon APAC となりましたが、皆様参加者多いおかげでPyCon APAC として始めたきっかけとなりまして、今回なんと2人のキーノートスピーカー基調講演ですね。さらに55のトークが今回2日間でありました。皆様プラスライトニングトークスポンサーブースなどもありまして大盛況となりました。皆様ご参加いただいた皆様ありがとうございます。
Yes, over the last 2 days, we had 2 fabulous keynotes and 55 talks, as well as many other content such as lightning talks, sponsor booths, etc., etc. Thank you very much, everybody who participated and gave a talk and attended a talk and asked questions during the talk. Yeah, thank you all.
続きまして今回2日間総合計ですね、参加された方、約700ですね。若干前後していると思いますが、今計測した限りでは700人参加されました。本当にこのだけの多くの参加者に来ていただきまして、本当にとても運営側としてとても嬉しいです。ありがとうございます。
Yes. As of 2 p.m. This afternoon, 700 people checked in Pretix at the reception. This is including staff, sponsors, and everybody else. And next, we will have a word from our fabulous network team.
ありがとうございます。日本語だけですね。はい、こんにちは。ネットワークチームで今回リーダーさせていただきました新光と申します。今回ネットワークチームでは Wi-Fi を提供させていただきまして、有志から72台の機材を貸していただいて本日の会場の方を支えております。トータルで、これは1日で引いたんですが、1セント90メートルの LAN ケーブルを引き回しております。よいしょ。はい、今回のトポロジーズ、ノックの方に、ずっと展示されていたんですが、それと今回の通信、これが16時頃、昨日から16時頃までの、結果で 2.1 テラバイトの方のトラフィックが流れています。また今回も IPv6 の通信の方がちょっと多かったかなというところで、多分ネットワーク関わっている方は少し嬉しいのかなというふうに思ってます。 はい、今回のノックチームの方を支えてくださった、スポンサーさんの紹介です。クラウドは IIJ 様、ホットステージの方はエブリー様、あと監視の方でニューリリック様の方の、製品を使わせていただいています。はい、あと最後にノックの、メンバーと、機材を貸してくださった方々の紹介です。このメンバーで、皆さんの Wi-Fi を支えておりました。ちょっと使えない時間とかあってご不便をおかけしましたが、ありがとうございました。
はい、続きましてアンケートの、ご協力のお願いです。こちら QR コードから、読み取っていただいて、ご参加、のご回答をお願いします。一部こちらですね、パーティー、今後のこの後のパーティー参加についてのアンケートも含まれておりまして、もしよろしければパーティー後に、今はスキャンしていただいて、パーティー後に回答いただけると、パーティーの感想も、送信できますので、ぜひ、記録読み込みしていただいて、後ほどご回答をお願いします。でまたパーティーは参加しないでこのまま帰りますよという方はぜひこちら終わった後ぜひ回答の上、ご帰宅ください。よろしくお願いします。
And before I explain everything, I would like to thank you all for for giving me that I didn't update the text from yesterday. When I copy-pasted this slide, the text on here doesn't really make sense. Anyway, please do answer our conference survey. This will make it so we can do next year's PyCon better, and we also hopefully make next year's PyCon APAC better. If you do join us for the party today, there's also questions about the party in the survey, so please answer it after that.
ですね、一応先ほどの QR コード後ほど URL を公式ツイッターよりも発信いたしますのでこちらもご確認ください。続きまして
Yeah, and we will also share the link to the survey on our social media.
はい、続きまして、開発コミュニティスプリントですね。スプリントを明日行います。場所がこちらではなく渋谷の変化株式会社さんで行われますので、参加される予定の方は場所を間違えずに、お越しください。10時から17時検討しております。こちらは無料ですが、お申し込み必要ですので、まだの方はプレティックスよりお申し込みください。
And yeah, the conference days are almost over, but there's still the sprint tomorrow. So everybody who still has energy tomorrow, please join us in Shibuya at the Henge headquarters for the development sprints that are from 10 a.m. to 5 p.m. This is free, but please do but you have to register on Pretix.
続きまして、公式パーティー、オフィシャルパーティーのご案内です。もうすでにご存知の方、申し込みされている方、ご存知だと思いますが、この後、こちらの20階の会場、ウエストホールの20階で、18時から行われます。今回、特別にオリジナルビールを準備していますので、お楽しみください。先ほどの入った情報ですが、ちょっと乾杯といいますか、受付をされたらドリンクを準備されておりますので、そちらを受け取って、乾杯、まずは待たず、ある程度まとまったら乾杯をする流れで予定をしていますので、ぜひその後18時からですね、お楽しみください。
And as you are probably aware, there will be an official party after this from 6 p.m. on the 20th floor. You have to have a separate ticket for that. If you don't have one yet, you maybe can still get one. I don't know. Anyway, more importantly, there will be a special original PyCon APAC 2023 exclusive beer. And also, when we open the room, there should be a bunch of drinks ready for you to take, and so we can do a kanpai together.
はい、続きまして、まだ受付をされてない方への案内となります。まだこのギグバンド申し込みしたけどまだですよっていう方がいらっしゃいましたら、中央受付ではなくもう20階まで行っていただいて、20階の受付で、QR コードですね、プレティックスの QR コードを受付担当に見せて入場を進めてください。またお酒飲めないよっていう方はぜひこのシールですね、このシールも受け取ってこちらの方のネームタグですね、こちらにお貼りください。
if you have a party ticket but you have not yet exchanged the QR code for this beautiful wristband, the place to do that has moved from the 4th floor reception to the 20th floor, and you have to do that before you can enter the party. Also, if you join our party but you would like to not drink alcohol, please get the no alcohol sticker and put it on your name tag.
はい、続きまして、パーティー内 LT があります。こちらは、抽選ですね、先着で、パーティーに申し込みされた方が対象となります。こちら場所ですね、上がっていただいて、パーティー会場にホワイトボードを準備してますので、パーティー参加されて LT したいという方は先着順で、準備してますので、名前をご記入ください。
And yeah, during the party we will have time and space for about 5 lightning talks. If you do wish to give a lightning talk, I have been informed that there should be a whiteboard somewhere to put your name, and then through some way we will choose who will give a lightning talk.
はい、続きまして今回ですね、約50人ですね。50人、今回来れてない、準備に携わったスタッフ含めると60人ぐらいになるのかなと思うんですが、今回、ここの会場にいるのは50人のスタッフで運営を行いました。スタッフ、こちらですね、昨日撮影して、今日はちょっとこのパーティーがありますので、撮影はやらない予定なので、この人数で今回、PyCon APAC 2023を運営しておりました。
So for this year's PyCon APAC, these around 50 people were the ones who made it actually happen. And this is a picture we took yesterday if everybody was here. And yeah, it takes a lot of people to make a conference. So thank you.
Thank you. 皆さん、スタッフの皆さん、ありがとうございます。拍手ありがとうございます。
And next is a message from the PyConJP Association.
続きまして、一般社団法人 PyConJP アソシエーションから、代表理事から、発表がございますので、バトンタッチいたします。
はい、こんにちは。PyConJP アソシエーションからのメッセージ。I will talk about some messages from PyConJP Association. This slide is English, but I told mainly in Japanese. Sorry. いくつか話します。About PyConJP Association。PyConJP Association についての紹介をさせてください。それから、皆さんが気になっているだろう PyCon APAC 2024と PyConJP 2024です。ごめんなさい。PyConJP 2024 2024 Sorry。について話します。はい。About PyConJP Association. Do you know PyConJP Association? Raise a hand. Half or thank you. はい。PyConJP のイベントと PyConJP Association 別の組織があるんですね。で、PyConJP Association は日本国内に Python ユーザーのために Python 広まってほしいなっていうことで、この PyConJP だったり他のイベントのサポートだったり主催だったりとかをしている団体です。はい、非営利組織です。非営利です。大事なところ。はい。ノンプロフィット。はい。で、はい。これがパス、Last Year's Board Members。よく覚えてください。Last Year's Board Member。で、間違い探しがありまして、2023年の2023ボードメンバーズはこうなりました。ということで、寺田さんから私に座長が変わりましたということで、今ここにいる理事、はい、理事の人、スタンドアップ、全員いた、はい、この5人で、この5人がやってますんで、皆さん顔をよく覚えて、なんか Python でなんかこんなことできねえかなとか思ったら、すぐ声かけてください。はい、こんな5人でやっております。ありがとうございます。みんないた。2023のアクティビティとしては、Python ブートキャンプっていろんな地域でやるんですけど、これが4カ所できたっていうこと。それから Python ブートキャンプキャラバンっていっていろんなところに行ってブース出してお話をするっていうことも、今年はインパーソンでできるようになったんでよかったなって思ってます。あと PyConJPTV っていう YouTube ライブも毎月やってますんで、もしよかったら見てください。はい。で、あとこの、PyCon APAC 2023でもいくつかアソシエーションとしての活動をしてました。で、この3つがありまして、まず、昨日ですね、アソシエーションミーティング。 yesterday we held the association meeting and so なんで俺急に英語で喋ってんだたくさんの人が来てディスカッションができてとても良かったです。とても良かったです。はい。で今日は APAC メンバーランチっていうことで、ただ単に集まってみんなでご飯食べましょうっていうことでキャッキャしてました。はい。参加してくれた皆さんありがとうございます。そしてあとちょっとあんまり時間できなかったんですけどもドネーション with グリッターステッカーっていうのがありまして、ドネーションをするとこのキラキラしたステッカーを得られる権利を得るっていうやつがありまして、でこちら、18名の方から14,500円、40,500 円をドネーションしていただきました。寄付してくれた皆さんありがとうございます。はい。でドネーションされたお金はまた遠方支援だったりとかそういう何か Python が広まる活動に使っていきたいと思ってます。はい。なぜなら非営利だからです。はい。NEXT。さっき理事が変わりましたけど、とはいえ5人のメンバーが変わっていないわけですね。やっぱりそれってどうなんみたいなのは僕たちも思ってまして、新しい人に入ってもらってもっといろんな新しい意見を欲しいですということで運営会議やってますんで、そういうところに来てほしいですし、運営メンバーっていうのがありますので Python ブートキャンプ一緒にやるとか、その Python ブートキャンプキャラバン一緒にやるみたいな運営メンバーとして一緒に Python を広める活動をやるっていう人も募集してます。そして、年に1回理事改選しますので、来年、1月からですね、1月からなので理事立候補とかっていうのも、俺今までこういうのやってきたんで理事になってこのことやりたいとかって言ってほしいなって思ってますんで、ぜひなんか気になることあったらパーティーとかでも声かけてもらえればと思います。はい。オピニオン&ヘルプウォンテッドです。それでは、PyConJP アソシエーションからの話は以上で、次にせっかく今回 APAC なんで APAC コミュニティの話をしてもらおうと思います。じゃあイクバルさんお願いします。
ありがとうございます。ほとんどの方多分ご存知ではないと思うんですけれども、私はイクバルです。APAC コミュニティの中ではいろいろマネジメントして調整していろんなコミュニティの間うまく皆さん、仕事できるように、頑張っています。言い換えればフロントエンドまでやってなくてバックエンドの API の整備とかあとプロトコルの選定とかやっております。ちょっとだけ、紹介させてください。APAC コミュニティはオンラインのでもやってますよ。We also have APAC community online. Just take a picture. これを写真を撮っていただいて、また後で、ゆっくり見ていただければかなと思います。これも多分あまり知られてないかもしれないんですけど、APAC コミュニティの中では16カ国、何らかの形で国レベルの PyCon をやっております。一番西側のパキスタンから東のニュージーランドまでやっています。If you are not aware of this, we have all these country level PyCons from the west. We have Pakistan, and then to the east, the easternmost is New Zealand, also known as Kiwi PyCon. How many of you have gone to any of these PyCons? Please raise your hands. 行ったことある方、どっかの国に行ったことある方、ジャパン、もちろんね、もちろんね。ちょっとトリッキーなクエスチョンですけどね。で、これ、国レベルの PyCon なんですけれども、ほぼ毎年ね、2010年からシンガポールから始まって、APAC 地区の、今年は日本、東京なんですけれども、やってきました。2010年。シンガポールから始まってぐるぐる回って、フィリピンやら台湾、タイね、バンコク、マレーシアとか韓国、あとジャパンね、はい、各の PyCon の皆さん、ちょっと日本以外の PyCon APAC 行ったことある方、Have anyone else been to other than the Japan PyCon? 少ないね。まあ。これから盛り上がっていきましょう。Let's go to all the other PyCons, APAC PyCons, okay? Right, so, yeah. で、2023年東京なんですけれども、2024年、2024 PyCon APAC. Where do you want it to go? どこ行ってほしいんですか？ どこどこ where Well、実はね、オンラインのコミュニティ通して皆さんと意見するので、投票を行ってきました。Dima, can you please come forward? 次の2024年のPyCon APAC の開催区に、コミュニティ The host of 2024 PyCon APAC will be じゃんじゃーん。
ありがとう、イクバルさん、ありがとう、皆さん。日本語は喋れませんでした。だから、英語で喋ります。So I will speak in English because I cannot speak Japanese. Okay, thank you so much for the trust for the APEC community. So for the first time, Indonesia will have a chance to hold PyCon APAC in 2024. We would like to all of you come to Indonesia. Indonesia is very beautiful. Maybe some of you didn't know what Indonesia is, but maybe you know this little island. It's called Bali, and a lot of you, I believe, know Bali is so little than in Indonesia. So don't come to Bali, but come to PyCon APAC 2024. We are gonna wait for you. And information about 2024. We already decided the date. It's gonna be in Yogyakarta, Indonesia, on October 25th to 27th. Yogyakarta is kind of like Kyoto for Japan, so it's not the main capital city, but it's a cultural city. So wait a minute, I have a banner actually. No. So see you next year. We would like to welcome you all in Indonesia. Let's come to Yogyakarta. Thank you so much for your help and then for your support. We're looking forward to hold the best PyCon APAC until then. So, みんなよろしくお願いします。
Thank you very much, Dima. Thank you very much. ありがとうございました。では皆さん行きましょう。PyCon 2024年、ヨガカタ行きましょう。
はい、Thank you, イクバルさん and ディマスさん。I want to go to next PyCon APAC, Yogyakarta, but I think Yogyakarta do not have the direct flight from Japan. Maybe Singapore or Jakarta. はい、なので皆さん頑張りましょう、日本の人。今から貯金しようね。はい、というわけで、PyConJP2024、毎年基本的には PyConJP として開催しているので、APAC は来年はインドネシアで JP は来年は普通に JP に戻りますよということで、2024どんな感じですかというところですが、はい、やるよと。ただしチェアパーソンはまだ決まっておりません。現在絶賛募集中でありますので、我こそはという人はぜひコンタクトしてください。で、日付は一応仮で会場も確保はしています。まあ変わっても別にいいんですけど、2024年の9月を予定しておりますので、インドネシアと被ってないので両方行けます。はい。You can go to PyConJP 2024 and PyCon APAC 2024。はい。はい。というわけで、以上で今日お話ししたい内容はすべて終わりです。皆さんご参加ありがとうございました。また来年お会いしましょう。See you next year!
And before everybody leaves, very important, photo time!
はい、皆さんお疲れ様でした。この後写真撮影、皆さんの集合写真を撮りたいなと思います。昨日参加された方はご存知だと思いますが、昨日と同じ感じで、トラック1で一度撮って、トラック2で撮ります。で、皆さんは移動しないで大丈夫です。それぞれでここで撮ってトラック2でも撮ります。なのでトラック2の方、ちょっとこう ライブでつながってるんですかね。そしてトラック 2の方、少々お待ちください。その後カメラマンが参ります。
Okay, everybody who has been here yesterday will know how this works. We will take multiple pictures, one for every room. So first we'll take a picture in room 1, then in room 2, and then I don't know if room 3 is in use, but if it is, then there. So everybody just stay where you are, and we will take lots of pictures, and you don't need to move. Our camera people will move for you.
はい、では早速トラック1の方から撮っていきたいなと思います。トラック2の方、もう少々お待ちください。あとライトをすみません、こちらつけていただけますか。
Okay, and
スタッフ、前の方にちょっと髪を支えるスタッフとしてお越しください。まあ私が行きます。あとすみません。
And yeah, while we wait for everybody to get in and ready for the picture, more lost and found. Yet another bag in track 3. Anybody else want a bag?
追加の落とし物です。
Also,
心当たりある方。
track 4, my bad. No, in track 4 there is a face mask, black face mask.
あとすみません、電気をつけていただき、こちらライトをつけられる、後ろの方かな。ちょっと昨日暗かったという意見がありまして、今日はつけていきたいなと思います。あ、いいですね。ちょっとすみません、スタッフか移動。すみません。トラック2でも撮るので、無理に来なくても大丈夫。はい、まずはトラック1で撮ります。じゃあこちらで、撮っていきますね。じゃあもうちょっと寄ってくださいということです。ちょっと引っ張ってこい。撮影します。3、2、1、スマイル。ありがとうございます。一旦トラック1は、解散となります。トラック2の方はちょっと少々お待ちください。今、横断幕持ってカメラマンもそちらに向かいます。
Thank you everybody in track 1. Track 2 people, please wait a little bit longer. We'll be right there to take your picture.
パーティー参加されます。